that you don't have to set up. Every time you go through some setup process, some setup sequence, it is painful. That's correct. And also the good thing here, like in these two cases, is to do git push, git commit all through all through your browser. So the idea is you hook it up to your GitHub account, and from that, in some storage location that you will put your files in, and once you have a point where you are ready to commit, you do git push. So after you commit, goes to your GitHub location, and from that point you can deploy your application wherever you want on the cloud, which is nice. And some of them I think are, so I haven't created any boxes, but I have used it in the past. And this one I think I used more than the other one. And you can log in through GitHub. So it already knows you from your GitHub authentication. And lets you in. Very simple. And you can continue developing your applications right in this browser without having to worry about where your machine is. I think I have some projects here, maybe at least one project you will see. So these are all the projects that I have on GitHub that I can just open up and clone it. And when I clone it from GitHub locally, it becomes available in the browser. I can edit it right there, deploy it from right here without having to go anywhere else at all. No need of using command line at all visually. So it's a nice one. Did you get a chance to read this thing, this write-up that I had that we discussed briefly the last time, which is this one with these 8 items that we want to cover in the next ongoing 8 occasions we meet in this segment. Did you get to read this at all, or briefly reviewed it? Or I gave you a link to that if you remember in this location. Okay, no worries, no worries. So we'll go there and start discussing. What I have is I'll pull up my notes so I can refer to them as I talk to you about what that goal book is and how it applies to what we are trying to do. Just one quick one. I want to go and check. There's a new person I'm expecting, Srinivasa Sama. Let's see if he's here. And we can start after that. No, he's not here yet. So we can proceed. I think Conrad said he's going to be late and Andrew is away. I think Andrew is traveling throughout October, so he may not be attending this month, but he comes back again later, is what I understand, for the 3rd month. So let me begin asking you a fundamental question, which is, from a company's perspective, what is the goal? What do they want to accomplish? What do companies do? Like, what's the goal? Make profit. Beautiful. How do you what else companies do apart from making profit? What's the primary goal? Let's put it that way. Is profit making the primary goal? That's philanthropy. Yeah. Yes, it is not charitable, institution. If business has to make profits, make money profitably, get a return on investment, and accumulate cash. So 3 things. Yes. Yes. And I'll give you an example just like that. somebody who built an awesome product and all of us use. His name is Linus Torvalds, and he created an awesome product called Linux operating system, and all of us use. Yeah, I mean, he's probably profitable by himself, by what he does, but it's not a business. He's not doing a business in that, at least in that domain. He may be doing other things, with Transmeta and other companies he works for, and some other things he has. I don't know, but creating a product per se is not the goal. Satisfying a customer need is, of course, a great thing. You can obsess about all day long, or all day long keep obsessing. How do you make the customer successful and happy? But at the end of the day, you have to make money. If you go to Las Vegas, you can invest some money there and lose or gain or win. But when I go to Las Vegas, you know what the machine I play with, I go there, I put in a dollar bill and get 4 quarters every single time. Have you seen that? No? Have you? You haven't seen the machine? Wow. Every single time. No matter what. Huh? So you understand what I'm talking about, right? Do you? It's called the change machine. Put in $1, get 4 quarters every single time. That's what I'm talking about. It's in Las Vegas, it's everywhere. It's called change machine. Put in $1, 4 quarters come back. Now that, by the way, is not 100% return. It is 0% return. You did not get anything. You did not make money, right? So that's not the goal. The goal is to actually create new money. New money as in get return on investment. So you put in $1, you get $1.10 back, and that is 10% return. Or maybe a little bit more money maybe if you make, a little bit less money you make, or sometimes you lose, which you get 95 cents back. You just had a 5% loss. So business is about creating new money, creating a return on investment, accumulating cash. So three things: cash flow has to be positive, return on the investment needs to be more than 1 or more than 0. More than 1 as in the ratio comes back should be more than 1. So in versus out the ratio. And needs to create profit, create money, create business, create something is what business is all about. And it applies to every type of company, no matter what. That's the common goal most companies have. So that's this goal is about. The book is all about that goal, is to make money, is to very clearly understand what is the goal. And so the book goes in terms of talking about, I'm not going to read the whole book for you, but this is a book summary essentially. I'll post it on the site so you don't have to take notes, but essentially the book describes about, let me, instead of reading the book for you, what I will do is give you nuggets or maybe ask you interactive questions as to what makes sense, because you can read the book on your own. I don't want you to read it for you. I'll identify some of the things that are very common, and it may be common in your company, in your entity, in your organization, or in your small group of people that work together. You may notice something that work accumulates and your deliverables are not done in time. Do you see that? Right, that's all the time. It's very common, like across the board. Every company runs into this problem. Stuff gets accumulating and things are not getting done on time every single time. You expect it to do, but it's impossible, seemingly impossible to do. And that's a problem. It's across the board. And in this manufacturing situation, they describe this problem of increasing inventory and unable to deliver service or unable to deliver products to the customer. That's how they describe this thing. Now, if you think about what would constitute a product that a technology company or a technology group of people in a manufacturing company like yours, what is expected of you as a group in your organization as to what do you provide? I want to understand that, and also want to understand what would constitute the element of work item. How do you track that is the key question. When you say, it's a rampant problem across every company I have seen is work items get accumulated and the thing that you produce doesn't consistently go out on time every single time. So what is that item that goes, and what is it that accumulates? What do you call these things in your organization? Work items, bugs, issues? Hmm. Yeah, yeah, yeah. I know. So you do have some kind of a board in which you will track things to do and things being done and things done, right? The to do, doing, and done, the three buckets. What do you put in their items? What are the items called? What do you call them? Stuff. And at the end, you produce an outcome which you give it to somebody who is your customer, probably internal, I assume. And that customer is looking to receive from you something. What do you call that something? Hmm. Hmm. Yes. Right. Right. Mhm. So from the thinking of the items that you carry in your inventory, in your to-do list, in your whatever list you maintain, in some kind of a board or tracker, some pivotal tracker or some what was that application you like Trello or pivotal tracker. Some of these tools will have a stack of stuff, stack of work items, action items accumulated. So from a IT industry perspective, we can call these items as inventory. These are ideas sitting in the pipe, waiting for them to go out. And what we as people do, people are the actually the raw material that process these ideas into outcomes or outputs or deliverables and give it to the customer. So if you think about identifying what is the goal again is to make money, how would your organization make money? Like by satisfying a customer's need or giving them deliverable. Is that how you would say you would make money in your team? Right. Uh-huh. Right. At an organization level, I think you're addressable, you're answerable to your customer, aren't you? If you don't meet your customer's need or you don't give them a deliverable, somebody will complain. Is that not right? And that becomes your deliverable. So in return, somebody is paying for your salary and your, the whole work your team does because you're consistently delivering to your customer need. That's why the company is paying for your division, for your group. And that's how essentially in proxy you make money, is by satisfying your customer, your internal customer. You're satisfying them consistently over time by giving them deliverables on time, ideally every time. And that's a way for your organization, your entity to make money because you're satisfying the customer consistently and repeatedly. So the corporation will keep funding you and giving you budget year after year so that you keep working on what the goal is. The goal in this scenario would become satisfying the customer because that's essentially translates to making money for your group in form of budgets that you receive and you're supposed to be delivering against them, against the commitments or against the deliverable you have. So the money coming in into your budget is how you essentially make money for your organization, for your group. And you spend that money on salary, on computers, on equipment, and whatever else that you do, and that's how you consume the money. The money goes somewhere, and money comes from corporate budget. Money comes to you because your customer is happy and satisfied, and repeatedly satisfied, meaning repeated budgets, annual, year after year budgets will keep coming to you. That's how I think you make money. You actually do. You make money by servicing your customer. So in return, you get what I call throughput. Throughput in a classic manufacturing sense would be items moving out or On the production pipeline, you have planes going out. How many planes every year? How many planes every second? Whatever that metric is, will become the throughput from a classic manufacturing perspective, but from the perspective of this book and the perspective of operations management, at least as it applies to software industry, the throughput word would apply to the rate of making money. How much more money do you make, or how much you make on a year by year basis or a month by month basis is the throughput, and you want to maximize that so that you get throughput. I'm tying it back to what you do for the customer. So the better you're able to service your customer every single time, customer is going to feel happy and excited that this organization of IT people are able to service our needs much more rapidly and consistently every single time. So if there is something new we want, maybe we can give them more budget. So that may translate to more money coming to you as a throughput. So from a throughput perspective, the definition in this book, in the context of this book, as it applies to an IT shop, which I would classify you as an IT organization, is your organization is servicing your customer needs and thereby getting more money from the corporation and generating more throughput, more cash coming into the organization, so you can do better things. Your individuals can grow, your work environments improve, you get to work on bigger projects, and those are all the benefits that you receive from working better consistently every time. So the aspect of receiving money into your organization over and over, year after year, is the aspect I would define as throughput, which is a flip of what a classic manufacturing does. Is the amount of stuff, whatever stuff you're making, you're going out, is called throughput in classic manufacturing. I would reverse it and say the money coming out from sales of stuff you give is the throughput. Does that resonate to you? Do I make sense? So if that is throughput, what is the inventory that piles up? Is the item that you want to work on. Right? And a third concept here, which is how do you get rid of the inventory? How do you reduce it? By working on it, by spending effort, time, money, people, right? You spend your people to get things done, reduce the inventory, and that what I would call is in cost accounting, the phrase would be what would I call it in expenses, if you will. You know, there are two types of expenses: capital investment or capital expense versus operational expense or operational expenditure. Two broad types. The number of the items that people will be doing to reduce the amount of inventory work items you have is the expense that you will spend. You will essentially spend people. That's the raw material you have to apply against your inventory to reduce it down, to make it happen, to give it out to your customer. So from an operational standpoint, the expenditure essentially boils down to you. You work on this and you work on this, and then we will finish it down and keep the inventory levels low. The more inventory you keep is the more expensive it becomes for your organization to actually consistently operate and produce output for your end customer. Does that make sense? So from a definition standpoint, I would use these three phrases, which is your throughput is the money coming in. Expenditure, operational expenditure, is the amount of time you will spend, or people cost essentially applied to reducing the inventory. The idea is to keep inventory low, keep the people expenditure also low, meaning don't overburden our people or don't burn them down. You can burn out people, right? If you work too much on a particular project, it's a big project, not too many people working on it, you can burn people down. You don't want that. Essentially, people are the machines here in the factory that are working on these items to reduce them. So keep inventories low by, at the same time, keep your operational expenditure also low by, without not burdening your people, and at the same time increasing throughput. That's the goal from your perspective. Even if you don't look at it that way in a classic organization in a large corporation. So you have a large company and you have a team of IT people working on servicing your customers and getting budgetary approvals every time to service your staff. And what you spend on essentially is people resources. So you want to optimize the game here becomes a 3 points being, you want to improve your throughput, money coming in. You want to reduce your inventory levels across the board, so the items to work on go down, and items being done all the way to the customer, and not spend your people energy or people resource too much. That's the way it applies to you. If you translate the same organization and put them outside Boeing, if you will, then you become a service provider of some sorts, and you're producing services or producing some software for some commercial entities outside, and they will actually pay you money. I give you service, you pay me. I give you service again, you pay me again. That's how most software companies operate at a global level. You being an organization, an IT organization within a manufacturing company is slightly different structurally, but the concept is same. If you just think of your entire IT department, take it outside Boeing, for example, and ask you to now give services to Boeing, Boeing will pay you for every service you give them in that case, right? Does that analogy fit into what I'm thinking? So the goal here becomes increase your throughput, reduce your inventory, and reduce your operational expenditure. Uh-huh. I see. Okay. Wow. I did not know. Thank you. So, I'm myopic. I don't know Boeing, right? Oh, I see. Thank you for enlightening me. I'm ignorant. I never visited Boeing website. Honestly, never. But you're the first group of people I met from Boeing ever in my life. Don't know anybody at Boeing. Don't know. Now I know. Now I know you. But no, I did not know anybody whatsoever. So are you from the making money part or the other part? Overhead. Right. So I don't, if you think like, you don't think like that. You're actually doing productive work and somebody's giving you budgets to work on it. So it's not overhead, but only managers are supposed to be overheads or CEO. Those people are the overheads who, the classic overhead example, right? Pointy head managers. You know that cartoon character? I understand. It's cost accounting gimmicks. It's about money, funny money. So it's cost accounting, funny money. So ignore that. Essentially, in any organization, you have to do something to get stuff done so you get paid. That's the bottom line. If you don't do it, nobody will pay you going forward. As simple as that. Whether you're overhead or internal or external or who knows what. You do stuff, you get paid. That's the bottom line cutting, cut down straight to the bottom. That's what it is. You do stuff, you get paid. If you don't do it, you don't get paid. Simple. And so the idea is to maximize your inflow of cash, which is your throughput, by reducing your inventory and reducing your operating cost. So what would be a capital expenditure? Where would it fit in? You buy a building, you buy a data center. Is that operational cost? No, it's data center upfront cost, right? Capital expenditure. So will you call it? Where would it fit in the three things? Because the whole book is all about these three things: throughput and inventory and operational expense. So if you spend $1 million on a building of data center, where would you fit in these three? Is it throughput? No. Is it operational expenditure? No. Then by definition, it has to be the third one, right? To produce output, to get cash. Whatever it takes to get cash is whatever you pay out to convert and get more cash is operational expense. The cash sitting in form of inventory or the buildings that you can essentially sell to make money is all inventory. That's how this book defines. It's a different way of defining it, and they have started a new. This is like an old book. I think 90s or 80s. It's a pretty old book. Yeah, it's a pretty old book, but they have started a new chain of thinking in cost accounting, in operations management, to redefine classic way of accounting practices. And that's what this book is about. It's a textbook, and I think it makes sense to me. Hope it will make it to you also. So if you think in that direction, throughput is essentially is money coming in. Inventory is the money currently inside your system where you're operating in, and operational expense is the money paid out. The whole building that you think of is, you can sell it, right? You can sell a building or sell a data center altogether. You can sell the whole company. So all of that upfront investment you might have made is inventory, because you just sold your inventory to make money. So it becomes inventory in that case, in according to this definition. Now let me ask you some other questions. When you're getting things done from your items in your workflow or in your pivotal tracker, if you will, you have this thing called a concept called dependent items, and also another concept of statistical fluctuations in terms of how consistently or frequently the output will change over time on repeat attempts. Sometimes I do eat this, I take 2 minutes. Sometimes I eat this and I take 1.6 minutes. It can vary over time. If I keep eating the same thing, the output can fluctuate a little bit. That is common. Like, so the amount of time a person will take to finish off a particular job in your Kanban chart, in your work item chart, will vary over time. The same person, same item might take different amount of time next time. So your predictability gets impacted. Predictability of output that you give to your customer gets impacted, because you don't know exactly how much will it take, because these are people, they're not machines. And even in the case of machines, it varies. There is always statistical deviation. You will see that, you will run into it. It's fact of life. So now I'll give you an example. The book gives this example of, I'll ask you this question about, say you are taking 8 young kids on a hike to this Tiger Mountain, all the way up top. And your goal is to make sure all these 8 kids, along with all their stuff, reach the top in the fastest, shortest amount of time. How will you go about doing it? Fastest, right? Mathematically, the fastest. Now, the kids are kids, right? They'll go random wherever they want. And so what would it take? What will be the mathematical way of thinking about this problem to take all these 8 kids to the top of Tiger Mountain in the shortest amount of time? It doesn't have to be like in 2 minutes, but just the shortest amount of time. What would that be? And you're not pushing any child. You're not lifting them by a helicopter and putting them on top. No, nothing like, no gimmicks. Just plain walk on a hike up the hill, and nobody's touching anybody else. So no gimmicks. Just plain thinking, apply some common sense math. What would be the way to reduce the amount of time it takes for the whole group, you and 8 kids, up to the top? I don't need a number, but I want to see the thinking. What would you do to optimize, to really optimize, to think about the problems like this? You have, let's call them, Alex, Bob, Charles, David, Elaine, Felix, ABCD, EFGH, all the way. H is specifically H. I call it Herbie, because that's what the book calls it. H is Herbie. And these are all types of kids. Some are fast, some are slow, some are fat. All types of people, like, they exist. And so these kids are all variety. Some are really fast runners, some are carrying heavy loads, and some are very lightweight, efficient. Some have proper shoes, some do not. Now, how would you optimize? How would you think about the mathematically most accurate, shortest amount of time? How would you organize or orchestrate the whole game so that the whole gang these 8 kids and you reach the top. And assuming none of them is disabled and like no, normal kids, normal human beings, they can walk. Some are slow, some are fast. And they're kids, meaning they're random. Random as in what you would expect by kids. They're human. So what would be the approach you would take is the question I have for you. And I'm asking this question essentially is because think of these kids as the items in your workflow, in your pivotal tracker, your items, things to do, and you want to take all these items done and then produce an output and give it to the customer. So you have an analogy here, which is these things that you have. Some of them are short, some of them are quick, fast, some of them are really big work items, some take longer, some take a different input. But you need to do all these things done, and until all of them are done, you are not done. You need to finish them all to complete a package and then give it to them. That's very common in workplace. You have things to do, there are lots of them, you need to finish them all to mark it complete. Otherwise you are never done. You're like, okay, I did 7 things, 7 out of 8, but I did not do the 8th one. You're not done. So how would you solve this problem? It's an operations problem. You do that, you deal with this in your workplace every single day. What do? Give me an analogical example of kids. What would you do? We do not want to slow down the fast one is one approach. Okay. But you cannot touch each other, right? The kids cannot touch each other. Encouragement. And you said one thing, which is you don't want the fastest one to slow down the slower guys. Meaning, if that's the case, you will have the faster kids running way up the hill, and the distance between the fastest kid and the slowest kid will grow like really long, and it becomes a scary thing for you as an adult. It becomes scary. So do you want to do that? Exactly. Is the smartest, fastest kid will run ahead of everybody else, and the slowest, fattest kid behind. And your blood pressure is going up. Like, what would you do now? You're a responsible parent chaperoning these kids. You cannot let the child run, and you cannot, the gap between kids will increase tremendously. That's the same thing as your work items inventory increasing over time if you don't finish them off. It's conceptually same, very analogous. So what would you think about the approaches? What do you think? The medium. Yes, please. Yeah, I think your thinking is right. Beautiful. Please keep going. This is exactly how it's going to work out. Just think about it. You're right, thinking right. Keep going. Yep. Yep. Mm-hmm. If I may, so if you have the fastest here and the slowest here, this is they will not be able to run ahead of these guys. Essentially, that's a very good approach. Now the problem still exists here, where B will run ahead, and the gap between B and D will grow. Your B will reach here because B is apparently faster than D, right? And you have C here, which is slower than lower than A. So this thing, the gap here will increase, right? So you have a gap increasing here as well as here, right? So you want to still contain the gap. Yeah, decrease, but cannot collide. It cannot go beyond zero, right? They'll probably hit each other, but then stop in some fashion. If you're making them file in line, essentially this A will start complaining, hey, D, move. How did you move? That might happen, right? So the way to actually solve this is like this. You will have D, C, B, A. Line them up like this. And now A will, go all the way to B and say, you know what, B, please go, go, go. And it will not go. The guys will not go, right? The slower guys relative to A, they will. The gap will be small here, almost touching. Small again and small again. You want to further optimize this game by looking at this group and examining their backpack. What are they carrying? And emptying the backpack and giving it to these guys. This is, I know, poor guys. You need to actually do this thing actively, and you can do the same thing actively in your workplace. You know how will you do this? This is called work rebalancing. If you have work items too much on one guy, the fat guy who's slow guy, you want to rebalance that, right? You typically do that. I know, but as a manager, you can probably do these things. You can, you can take work item from one person, give it to the other, for you come up with a logical reason and explain to everybody, and then do it. And so this is a way to look at the backpack of D's backpack. Look at D's backpack. See what they're carrying. And in this example of the book, it's actually like this. So H is the classic name. This name Herbie is very commonly used in the industry for the H kid, or the slowest kid, or the fattest kid, or also known as the bottleneck. Right? This is the bottleneck. That thing has to reach. I mean, I'm calling it a thing. That person needs to reach the top of the mountain, and then everything falls in line. That's the slowest guy. And you want to line them up like this, or be on top, and actually put a bungee rope in between kids. So it's some slack. You know what bungee rope is? Elastic bungee rope, and between H, G, F, E, all the way down, and you are behind A. So you're basically supervising the whole gang, and have them hold. But you must have seen like street crossing near schools, kids crossing. You might have seen small kids filing up, holding a rope in their hand in this country. It's common. You may have actually done that as a child. No, haven't. I see it in some Amish occasionally, kids crossing road, or with a rope in their hands. Okay, you're too old, I guess. But I know, but I've seen these kids. I think it's a good game. I mean, it's a good practice to have kids fall in line, hold a rope, and just walk along. And they're doing it. They're probably not thinking like this of sequencing them, because they're not trying to rush it. They're going casually walking, but make sure that everybody's filing in line, holding a rope, and just walking casually is a good practice that schools seem to have adopted, which is nice. What it boils down to from a work item perspective is that if you have a slow item, or slow machine, or a slow worker that is going to be applying his or her work time onto a project or an item or a work item, you want to look at that from an operations perspective, understand who is slow, understand who is fast by measuring them and allocating them appropriately, and emptying their backpacks, giving them proper shoes if they don't have them, but making sure at the same time they're working all the time. Don't make them stop. If that guy stops, the whole thing stops. You're wasting time now. So on one hand, you are getting rid of the heavy items that they have in their backpack, unnecessarily carrying all the way up the hill. But on the other hand, you will make sure that Herbie doesn't stop, because that's the mathematically the fastest way everybody can reach the top is the slowest guy. Is that right? And so apply these concepts to your operations in your workplace. Identify the slowest worker, and it is actually hard when it applies to humans. You don't want to really call them, hey, you are the fattest, slowest guy, man, come on, work all the time, 24 hours, cannot even get lunch break, because I will feed you here, eat right on the spot. As a manager, I'll bring lunch for you, give it to you, you should eat right here and keep working and don't sleep. That's what you want, right? This is very crude, but that's what mathematically you want, is this, you want that bottleneck to keep working all the time. You can reduce their workload, but you want no downtime, because that is really expensive. You see, when I say expensive, you get the point, right? You're not producing output. When you're not producing output, you're not getting throughput, meaning money. You want to get money, you want to find out the slowest point, you want to find out the bottleneck and take good care of them. When I say good care, I mean both ways. Keep them working, but alleviate their pain, right? That's the key summary of this, which applies very nicely to what we do every day, is to identify the bottleneck, the slow guy. In IT operations, it is typically a guy or a girl. It's a human. It's not a machine. It's not a machine in IT, in computer science or any software development. It is always people that are the resource, because all you're doing is actually thinking and doing something. And it's not that you're manufacturing a plane. You may be, but not in the IT department. All you're essentially doing is creating some software, some service, and producing an output to make it happen. And you want to optimize, you want to actually maximize your throughput, not optimize, but maximize the amount of money coming in, because how you make money is actually how you produce services and deliver. So you create and deliver most efficiently that you can, so you can make more money. That's the game. And it applies to every industry, including software, including IT, and you and me. We need to find the guy. And so it is also important to look at what I just said, the bottleneck, which is important. You may have seen, new techniques or new technologies implemented in your company, something that is nice and fancy, a new tool like Chef. Who knows? We'll use Chef pretty much later today. We start with Chef at least today. So a new tool comes in. It's all nice and shiny. Does it get you actual benefits? So you have a new robotic system that gets implemented in your organization. Does that actually make your life productive? Make you productive? Do robots make things productive? That's the question. What do you think? Does it make business productive, more productive if you bring robots? Yes, they can do things faster, but is it productive? That's the question. So what is productive and what is not productive? Let's understand that aspect. What is productive? Yeah, robots can do magic things, very fast, very efficient. I understand. They're very expensive. Yes, I understand. But are they productive? And what is productive? What is not productive? That's the question. So what do you think? Yes, if they make money, productive. If they don't make money, not productive. See, at this moment, I'm eating these chips. Does that make me productive? Actually not. See, I'm about to cough. So is it productive? No. But I'm still eating them. I'm sorry. They're very tasty, by the way, but very spicy, so I might cough. So robots can be a good thing, but only if they are making money, if they're generating throughput. or if they're getting rid of people. That was a very crude way of saying it, but practically that's what it is. Right? If you bring a robot, you need to fire people or reallocate them somewhere else. Otherwise, there's no point of bringing robots. You can put robots only if and only if they're productive in the way that you make more money. So you put robots only at the bottleneck, not otherwise. I don't want no robots in my company. I want no automation in my company. I don't want to spend any money for automation in my company any time, unless it is bringing in more cash. I do not want to waste money or effort or energy or investment in anything that does not generate cash. As simple as that. It may be fancy. It may be, a new iPhone or a God knows what Tesla or any magical thing. It's not my business. My business is strictly looking at what is the thing that makes money and how do I improve that to make more money. And that's the only way I will spend money, is because it increases my money coming in. Any other investment, any other expenditure is irrelevant, totally irrelevant, because it doesn't make money. Why would I do that? I'm strictly talking business. That's the point that this book drives. I think it is totally on the point. Yes, robots are good if and only if they are productive, meaning they're making more money for you. Just because the boss said, you know what, buy a new fancy robot that will do this thing. Who cares? It is not the bottleneck. All I want to really do is produce more products so I can get more money. And if the robot helps me with H, they hurry, the bottleneck, then I want a robot. Otherwise, I don't care. I do not want a robot, even in a developed country, because it is irrelevant to have a robot if it doesn't make money. It has to be productive. So, having said all that about the aspect of a bottleneck, they're the slowest, fattest people. They slow us down. I call fat because I am fat, but fat is not the physical attribute I should think of. It's how you mentally operate, how efficiently you operate to get a work item done in an intelligent workplace. It's not about physical fatness. But I'm just figuratively saying saying that word. They are a bottleneck. They are what they are. So is having a bottleneck a good thing or a bad thing? That's the next question. What do you think? And don't look at my notes. So what is it? So is bottleneck a good thing? Yes, yes, yes. So is having a bottleneck good thing? Yeah. Yeah, if you remove a bottleneck, the bottleneck shifts somewhere else. But if we have like a beautiful scenario where there is no bottleneck at all, like very efficient workers or good manufacturing capabilities to produce like Boeing planes every hour. Yeah, I'm just saying, no bottleneck. You have it, do whatever you want. Is that a good thing? Is no bottleneck a good thing? Logically, it sounds like it, but you know what? It is not a good thing. To have no bottlenecks is not a good thing. It's a bad thing. Here is why. Think of you as somebody outside Boeing. Okay, let's for now. Think of you as company, your people, and you're running this show. And you seem to have no bottleneck. You know what that means? Is you have the most expensive employees on the planet Earth that can finish off any work item you give them at a moment's notice, like this, fast. What I just said is you have the most efficient people on the planet Earth, which means you have the biggest salary payout on the planet Earth, which means you're the single biggest loser company on the planet Earth, because you're paying out salary huge. It's so expensive to hire smart people, right? So yes, you can have a zero bottleneck, but it will be so much over capacity that you will die in your business. I mean, die as in economically die. You'll make losses. You see what I'm saying? So having a bottleneck is okay. Using it efficiently is very important. Not having a bottleneck at all is bad, like really, really bad. You know what it means in very practical terms is that you are way overspending. To write a hello world program, you just hired this gentleman. Ouch. Hurts. I just wanted a hello world program, man. Come on, a kid can do, teenagers, high school, no, not even high school, third graders in India are doing hello world programs. You hire them, not this guy. He'll drown your business on his salary because all we do is write a hello world program. You know what a hello world is. So will you hire this guy for hello world? I don't think so. That is way over capacity. There is no bottleneck. I don't want him in that company. He may not even come, but that story apart. If he actually comes, you have a problem. The problem is that you don't have a bottleneck. Having a bottleneck is an awesome, awesome thing. It's kind of very counterintuitive, extremely counterintuitive. I have no bottlenecks. Oh, wow. And that is such a loser you are. Practically speaking, that's what it means. If you have no bottleneck, either it means you have a huge amount of capacity in your manufacturing capabilities, or you have the smartest engineers on the planet Earth writing a hello world program. See that? That's the problem. So bottlenecks are a good thing. Just optimize around how to manage them and keep looking where they shift, because bottlenecks will shift. You know how they shift? When new work comes along, a new item comes along in your list of things to do, a new project comes in, you have a new bottleneck somewhere else. You have to keep studying where the bottlenecks are. How do you do that? Well, looking at your people, how they actually complete work items. So you may have seen charts of variety of types where somebody is actually measuring the rate of depletion of your inventory or rate of finishing up a work item. How many days did it take for the entire team to finish off this work? And they'll track progress on a week by week basis. What do you call that thing in your company? Are you measuring this thing? You see what I'm saying? These are called burn down charts, or some other charts that you can, different companies call it different things, but essentially you're measuring how efficiently you are processing your work and getting them done and giving it to the customer so you get paid. So what do you call that thing, and are you measuring it? And that's great, but if not, please start right now. Start measuring how are you doing. Otherwise you have no idea. You have no idea how you're doing, which is really, really bad, because you're operating in a blind. You need to know in your company, in your organization, across your team, and even across other teams that you work with, to know who is doing how much. Not just what, but how much. People focus on, okay, I'm doing this or I'm doing that, and my role is this. Cool, I understand. Tell me, how much are you doing? What you said you think you're doing is important to measure. That's the only way to find out where is the bottleneck. Are you actually doing it? You think you're doing, I'm the chief of blah, whatever that blah is. But are you getting things done? You may be the chief of God knows what. I don't care. Are you doing it? And how did you do for the last few months? Let me see some numbers. That is so important to find out. How did you do? And not just you, but each and every one of you in your entire team, in your entire organization. It may not be at the Boeing level, somebody else will do it. But let me tell you, they're doing it. If you do not know, they are doing it. They're somehow measuring how you're doing, each and every person, and trying to assess your capacity of delivery. How are you delivering? They're measuring it. If they're not, let me come and talk to them. Honestly, this is a serious business. This is how companies succeed or die, is to measure how you're performing. If you're not measuring, you're not doing it. You have no idea. People in many big companies have this, what I call It's a big company disease. When your company size becomes more than like 500 or so, you get this disease. Because nobody knows what who anybody else is doing. And not just about what they are doing, but how much they are doing has no idea. Nobody has this idea of how much did I do. And that, I think, is a necessity, because that's the only way to find out how you are doing. You can claim I do X, I do Y. Yeah, big deal. Tell me how much is the measurement we need. And it boils down to identifying where your where your bottlenecks are and studying them every month, every week, whatever that periodicity is appropriate, to figure out where your problems really lie. Now, when it translates this thing back to our day-to-day work, it essentially means measuring the tracker of items. So how many days the tracker item has been sitting on a person A plate, on your plate or his plate or somebody else's plate, and how was the history of that item, and how did that finish off, and get new items after it is done. What is the rate of their processing? It is similar to the rate of stuff getting done. It's, think of it as joules per second in pure physics terms. Things of work is the unit of, joules is unit of work. So how many joules are they producing or spending or creating every second? So it's the wattage, is the capacity of them to deliver. And this, if you take that, the wattage and joules are very physics oriented terms, so ignore that. It doesn't really apply in brain power. You don't really consume wattage, but you get the point. You need to measure that. And also watch it over a period of time for patterns. And period should be like a long period, like 6 months, maybe a year, as to how has been the change over time, because people fluctuate. Sometimes I do a particular task faster than I do other times. So over time, what's the consistent pattern? And this is a way to measure capacity of a team, how much work a team can do. And then throw a good big new work item against a team. Hey, can you do a big item this time? And give them more work, which means the bigger budgets for your team, which means more salaries, practically speaking, right? You get bigger work items, you get bigger computers, bigger stuff, better offices, whatever you want, you decide, but you get to work on a bigger project, which means more money, a bigger title, or whatever that is. But basically, it's more money. It's all about the money in a business. Get that? So measure is critical. Measure for patterns, measure at the individual level all the way to team level, to understand the capacity of a team to perform. And then at a corporate level, people measure across teams. How is that team performing versus this team? And compare across teams. So who should get a new project should be based on a team capacity. Can they finish it off in this amount of time if you give it to them? Do they have the capacity to do it? Is where this thing translates back to, this concept that I just described to you. And yes, the first time you think of no bottlenecks, it looks really heavenly, but it's very expensive, as expensive as heaven can be. And you don't want to go to heaven, because to go to the heaven, you need to die. I understand. The last time I checked. Let me find more nuggets for you. And yeah, here is one, 79. Bottlenecks are only working on quality products. Don't give them unnecessary stuff that other people can do. It's very important, critical things that you need to get done for the pipe. You heard of this thing called, what is it called? You heard these terms before? The critical path you have? That's what I'm really talking about, is identify the critical path towards success, because you want to get to the end of the project. So here are the red lines. You've seen this called Microsoft project, right? This picture, you must have seen it somewhere. You use the software. You haven't? Okay. So this is a Microsoft product. It is called the Microsoft Project, and it essentially shows you a product launch. In this example, product launch project, and they have defined some stages and some timelines. And in the black lines have some slack. The red lines do not have slack, and slack is exactly what it means: opportunity, a room for slacking out. No slack in red. Black has some slack time. Red does not. So red becomes the critical path, and you want to make sure to exploit your bottlenecks essentially as a red line. You want to keep them fully exploited. Exploited as in, when it comes to people, it becomes very harsh sounding. But if it's a machine that is producing something, you want to keep the machine turning on, up and running all the time. Even if there is no electricity, you put generator and keep it up and running. That's what it means. When it comes to people, it becomes different. Then you have to still find a way to keep them fully occupied all the time. 24 hours a day becomes hard. So 8 hours is reasonable humanly. But then what about lunch break? So all these things matter, right? So if you're a really mechanical person, you would say you work 24 hours a day, no lunch breaks for you. I'll bring lunch for you here. I'll feed you by hand. And you keep working. That's how a mechanical analogy would apply, but it doesn't make sense in human beings. But I'm just giving a point. So the red line is what I just called is known as a critical path, and that's the mathematical representation of a Gantt chart. So read more on this if you like. And one more thing here, which is I think the last thing in the notes, is to prioritize. You have work items that accumulate in your chain or in your tracker. What you need to be worrying about is to assigning a sense of priority to which is more important than the other, and give the priority items a sense of priority to finish faster than anything else. That's common sense, but that's also important. Sometimes some companies miss out on that. And so in Pivotal Tracker or in Trello, you have a sense of priority that you assign to every work item in the tracker itself, that you should revisit over and over in every periodic meeting. Is the priority still accurate? And then realign and readjust, because that gives a very clear indication of the people who are taking on work items. Which one do I take on first? The priority one or the other one? That's obvious if the priorities are clear. If they're not clear, then somebody has to make that judgment decision. And a person at an individual level may not have the right view into what the global priority is for an organization. So it is important at the organization level, when you're looking at a team level, group level, when you look at all the work items, when you're triaging them in terms of issues, how much time will it take to finish it off, getting it complete and giving it out to the customer. You want to assess priority of all the remaining items every time and readjust them as needed. So that's the fundamental background or the underlying thinking behind this book, which I think applies to everything we do in any business. Now, when it applies to operations in IT and developing software and services to give to a customer, we have to think these frames of reference in context as we work on them. Now, when we prepare products or services, we use some kind of a application programming language. Like, he likes Python, or some people use other languages like .NET. Some programming languages will be used to create something meaningful. And that becomes an application in itself. But when you want to deliver a service to another entity these days, it is common to produce services as opposed to software. And you've seen that in several examples we have taken in the past, which is Office 365 became a service available from Microsoft, as opposed to the shrink-wrapped box that used to be sold at Staples. You know that, you've seen that. In Staples or in Office Depot, you can buy, even today, a $500 or $600 box, which contains every single software from Microsoft, including Microsoft Project that you just saw. And all of these software together have been streamlined in form of a service available on the web, which is the Office 365 service. And almost every software company these days is transitioning like that. In fact, there is a new consulting operations from major consulting companies that is called it's a made up word, but the idea is to SaaSify your software. You heard this before, or the concept is not new. It's happening for the last few years. Is to SaaSify your software. So is TurboTax a modern application or not? Yeah, it has been modern for quite so many years. So this is the service offering. You can buy TurboTax as a product in Costco for $70, or you can go TurboTax on the web, turbotax.com, and use it there without having to install any software locally. The same software, same everything, including filing and all that, but as a service. So this SaaSification or availability of software as a service is happening across the board if it hasn't happened already. So you know of this tool called Adobe Creative Suite that has now become Adobe Creative Cloud. You heard this already. The transition has happened. And Office, the software, to Office 365. So this is happening already across the board. Every industry that uses software, sells software, is SaaSifying it. Our idea in this class for the next for the remainder of this curriculum would be to find ways to produce software as a service for our customers and create them and develop and deliver to them in what I call as continuous some of these phrases that come to mind that I think I should highlight before we jump on to the actual mechanics of making it happen as to what it takes to actually deliver and continuously iterate on what customers want. And so what I would like to now ask you is give me a few examples of scenarios where you may have asked, you are the customer, you are the user, you may have asked for somebody to give you something from a service delivery perspective, and they delivered it to you like much like in a few days after you ask them to fix something. A service provider that you are a customer of, you ask them to do something and they do it for you. Have you run into that situation, or have you ever given a feedback to a company that produces services for you and they fixed it for you? Mm-hmm. So network elements, storage elements, application delivery elements also. So here you're talking about your role is a service provider as opposed to a customer. Are you consuming these services, or? I see. So you are actually, so you are consuming and delivering what? So when you consume network, you essentially get internal bandwidth allocations, IP address ports, routes, things like that. And storage as in NAS or SAN, iSCSI, you will. So from a consumer of storage services, did you ever ask somebody to give you something and they gave it to you like in a matter of few days, months? Yes. So the same thing again. eh, Yeah, I know it will improve. I think the things will improve, no doubt about that. But I think at some point the expectation of delivery becomes continuous. Meaning you ask for something and they're able to give it to you right away, or maybe at a moment's notice, maybe at a few days' notice. Is the expectation that consumers have grown to expect. Is you have a bug, we need it fixed by tomorrow, and you have it. That's the expectation people have. And that the underlying thinking behind all these continuous integration, continuous improvement, continuous delivery, the idea here is customers may need something, they will ask us, they will give us throughput, right? We'll spend our operational expenses, the minimum amount of operational expenses, and still produce throughput from them, because they will give us money, we give them service. We'll produce services, our inventory will go down because we give them service. Our expenditure that it takes for us to spend on, which is our operational expenditure, will be minimal because we do most of it automatically. All we need to do is listen for what the customers want and do it, so we can give it to them so that they can pay us money. That's the whole idea behind the CI movement, or continuous integration movement, is to make more money by doing it most efficiently at the lowest amount of cost you can get away with, while at the same time still giving good service to the customer. To pull it off is not magic. It is grunt work. To really plan ahead, and years of practice and planning is needed to make it happen. That's why it is very normal and natural for a storage or a network provider to take a couple of months to give you what you need, because they're not wired to produce what you need at the moment's notice. So it is reasonable. Maybe not reasonable going forward, but at least it is reasonable right now. So from a CI perspective, from an operations perspective, from a software and services delivery perspective, or what is referred to as the DevOps perspective, the perspective here being you are able to deliver infrastructure services and platform services to your internal customers, meaning you are writing some software, you are creating new services, and you're delivering it to your customers. So there is both these elements of developing and operating come into play in your organization. Is that a fair assessment? That you will have to deal with both development of new products and services and delivering it to them is the underlying idea. So to be able to build what I call continuous delivery solution, you need to not only deliver what you create, not only develop but also deliver what you create. So anything you create, let's say a developer makes a new component of a product that fits into a bigger scheme of things, the better you deal with whatever you do in form of software is ideal, because software gives you the agility to produce. When I say this network guys cannot give you more bandwidth overnight because they have to actually put in physical pipes. But imagine if that was defined as a software defined networking setup. You heard this term before, right? SDN. So when you have software defined networking and you have capacity to handle the entire Boeing organization, however, in certain cases, Nitin wants me to give him a little bit more bandwidth or a little more network endpoints for a specific new deployment you want. So if I am structured like SDN, I can potentially come back in my workstation, make some software modifications to make it happen for you, keep you satisfied, and tell you, hey, I did it for you in 2 hours. And that is possible only if you have the ability to maneuver what you have already. So when you have an organization that is a large company like yours, and you have capacity that you can potentially reallocate from one entity to the other, and not 100% occupied all the time, meaning if you have, let's say, a CPU here, this compute activity. Let's look at the computer activity. Right now, if you look at my CPU activity, what do you see? Something is occupying 64%, not anymore. So Google Chrome is the most expensive, 1.2% consumption right now. That's what you see there. And if I'm working so hard on this machine that I'm keeping the CPU 100% all the time, is that a good usage of my computer? Yeah, you cannot do nothing about it if something comes along. So keeping 100% occupied is a bad idea in general. You need to have some slack somewhere so you can service. And so if you're running into 85% or more CPU, it is good time to look at another computer, either a bigger one or maybe two or three to divide the load. So you want to keep them at least about say 85% of usage on CPU at the max, at the most if it's a production server. This is not a server, but I'm just giving an example. The same concepts apply to when you have a bunch of SDN and deployed across your company, and it is software modifiable. So I can address your need and address his needs also because I have some reserve capacity that I can allocate to you. So that agility gives me the flexibility to give you what you want at a moment's notice. I can pull it off if I keep everything in a Git repository, if you will. My entire configuration is stored inside some repository. All I need to do then at that moment is to come back, test out the changes you want, and then say git push or git commit, git push, and then I'm done. That's the outcome that we would like to see. I bring up an example of Git is because it's a very good software, it's a very good option to store and modify configuration. It's a very good option to store and modify software or source code, whatever you put in there. It's a very disciplined way of controlling things. And so if you want to have an outcome where you are able to deliver services at a moment's notice and are able to produce that for somebody, for your customer, by making a software change in your company and are able to service them, it is important to keep everything that you have in version control. And that's what this concept of infrastructure as code comes into play. Have you heard this phrase before? Okay. So the idea is to define your infrastructure in code and treat your infrastructure as code. And Chef is one example of one way of doing it, essentially. It helps you define your entire configuration in the form of some code. I'll now go specifics in terms of what Chef can actually do and what it does for us. So we'll slowly go deeper into that. And your virtual machine is set with, do you have virtual machine running here or does it run at all? But yep, yes. So we'll give that a shot whenever we get some time. Don't worry about it right now. I'll get to that point, get you that point. So the idea behind infrastructure as a code is to basically put everything that you define in your infrastructure, not the raw boxes you get from EMC and Cisco, not that, but the ability to configure them and reallocate them and divide them into chunks and distribute across your consumers of services through software is what comes into play, right? So when it applies to cloud providers give you APIs to manipulate your infrastructure the way you want. So a simple example I'll try to bring up right now, and I'll show it to you here. Let me pull up a good example. So a simple example would be something like this. Knife EC2 server create. Now this will be a call, an API call into the Amazon EC2 cloud. Are you able to read that line, right? Knife EC2 server create and options. So the idea behind this would be, once you have everything set up from an operations perspective, you will run this command to create a new server in the cloud and then deploy it the way you want. One single line and does the whole thing. So from a usage perspective, it will something be like this. I'll go to DigitalOcean and set up that box that we have here. So I'll create a droplet. I'll call it, let's say, build something dot today. That's your domain, right? And it doesn't have to be a domain name. I'm just saying www.buildsomething.today, and just giving it a name. It's the machine name. This is not the domain name, although it's very clearly calls out. It's a droplet host name. It is not the domain name. So that's the name I want to choose. Select some machine size, select a region, and pick an OS, select a key, and off I go. So I'll basically create a machine right there. I'll go cheaper, $5, and build something today. New York region, Linux, Ubuntu. Select a key, that is important. You need to have a key, and then create a droplet. I just started a machine. You can do the same thing on a terminal by saying knife, DigitalOcean, droplet, create, and then in there you go define parameters like machine size, location, geography, availability zone, networking type, and then use my key and say okay. So it will go and do the same thing what it is doing visually in a mouse click. But that doesn't complete what we want, because what we just got is a box containing Linux. It doesn't run build something today website, does it? No, it doesn't. It does pretty much nothing except gives us a terminal with this IP address here. So I can go to that terminal and say that, make it big so you can see, and say SSH root at IP address, and I logged in. But that's pretty much, hold on, I need to remove. And now I'm logged in. Practically there it is. So this is uname, and it is build something today. So you just connect it to that site, and but it's meaningless at this moment. I want to do something actually meaningful as opposed to just creating a box in the cloud. It's pointless. So now if I want to say that the customer, this guy, is expecting a WordPress site ready for him to deploy right now, so what do I do? And so without me struggling with creating what you just said you wanted, what I can do is come out of it, go to my chef repository, and in there, check whether I'm clean. So I'm doing a quick cleanup, and I'll demonstrate to you in the next 15 minutes or so. We will have a WordPress site up and running, just like that, hands-on work. It will happen automatically. You will see it right now. Have you seen this before? No? Okay. So let me just quickly check sanity on this one, and I will proceed. So what I'm going to do now is ask my customer some more information. Hey, what do you want to actually call your domain name? Is that the www name you will use or something else? That's the only question I will ask my customer. Do you want to use the name www or not? And that definition, I will go and put this in this file location here. So the customer needs to tell me whether he would like to use the name www.buildsomething.today. Is that the name you really want, sir? And that's the question to the customer. And so the customer says yes. And so I make these changes to my file and I save it. And then I come out of it. And all I need to do here at this moment is to say knife solo bootstrap. And what this will essentially do is just watch. I'm going to run, hit enter, and just sit with you and watch what's happening. So I just hit enter, and now watch it. And what it is going to do is watch carefully. I'll enjoy some chips with you while it is doing. So as you will see that it is bootstrapping Chef at this line here. What it is doing is installing Chef on that remote machine. And it will take about 5 minutes to finish off the process, but keep observing as to what's going on. And you'll see that it is unpacking Chef at the very last line and installing Chef 11.14.2-1. Then it is gathering a bunch of cookbooks from my machine and uploading the entire kitchen. The kitchen is going to that machine out there. So it takes a little while for the machine, for the entire kitchen to upload. And then it will take that entire kitchen containing all the cookbooks and run each recipe. The recipe is structured in such a way that it installs Nginx, MySQL, PHP, FPM, and with a root password, and sets up a host file for Nginx with your domain name www.buildsomething.today. And so if you can modify your DNS records for www and point it to the IP address we got from them, it will start working in a few minutes. You will see that. So the IP address was 04. I'll come back to it, but whenever you're ready. Yeah. So it is what this is doing is now running the recipes right now. So here you say MySQL client action create. It's setting up MySQL client on that machine right now. Now it's installing it. So the point behind infrastructure as code is whatever infrastructure I need for my customer is I've already defined in a Chef repository, and I'm installing whatever is needed to make it happen automatically on that machine in the cloud. And when it finishes, it'll report that it is done what I wanted it to do. And it's live running example. We can actually play with it as we speak. So once our customer is able to modify the records for his domain for www a record, the IP address I will give you in a few minutes, and then we can visit that location and load WordPress and enjoy. All we needed to do was to define what outcome we want, what infrastructure outcomes we want, and we define that in that Chef environment, and it is doing it for us. Now there's a specific way for us to define the outcome, so we don't have to tell them how to do it, but the what needs to be told. It doesn't know. It does not have a mind of its own. It doesn't know what you want. You need to tell Chef what you want, and when you do, it will do it for you. Gladly do it for you. repeat any number of times you want, it'll do it. And so it just finished. It says chef client finished. Something happened, 82 seconds. So it did something apparently. Let's find out what it did. So I'm going to go back to that machine again, SSH, and go there. So when I go there, I want to give my customer the IP address so that he can then do a CNAME a record creation for www. The IP address is 104. Yeah. 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 Now what you would see here in this machine is it has MySQL installed. See that? It has PHP 5 FPM installed. It has Nginx installed and ready to use. I can actually go log in to my SQL database and create a database for my customers' use. I think I closed something by mistake. I'll open it up again. So database creation instructions is what I'm looking for, and give me just a sec. Yeah, found it. So first instruction is to log on to the MySQL database. Password. Password incorrect. What is the password I chose? Here. My password is this. That's the password I chose, so my password was wrong. Now I'm inside MySQL. And inside MySQL, what I need to do is where was I before? Yeah, here. One line, second line, third line. I created my database permissions in user. Yeah. And I'm going to come out of my database. The next thing I want to do is grab WordPress, load it up in the right location, and we should be off and running. So I'm going to grab WordPress now. WordPress is available again on the same location we already know, which is wordpress.org. We'll go there, grab download link from here, copy that link, and bring it to terminal. And so on that remote computer where we are right now, we'll go to a specific location where we want. And in that location, create a folder called www, and then go inside that folder and then download the package WordPress like this. And it downloads. Then we'll look at the package and then unzip the package. and it's unzipped. Then I look at the content again. I have WordPress folder. I will rename the WordPress folder to whatever we call your name. Your customer name is www.buildsomething.today. Enter, and then I'll do a file permission change, which will be something like this. What did I miss? Oh, it's not MOD, but OWN. Yeah, now permissions are all set, and we should be able to visit www.buildsomething.today, and boom, we go. Oh, it's not propagated yet. Okay, change your. Are you on Route 53 or where are you? Okay, change your time to live TTL to 1 minute. TTL 1 minute, 1M. Say. Yeah, it'll come up. It'll pretty much come up in just a few. So this, once this propagation finishes, we should be able to run WordPress and see it and all that good stuff. So it's ready. So time it took for us to build out complete setup. For how much? Minutes, probably few minutes, maybe more, 10 minutes, 15 minutes, not more than that. Now, if my customer wants me to change something, I can always go back to my Git repository and run it again. What did I take? Another 15 minutes. It is still better than 2 months, right? So the idea is to automate. The idea is to write your infrastructure as if it is code, because the whole thing is software defined. Most of your infrastructure is today, the modern infrastructure is definable through software. That's why this phrase comes along, and live. And you will see this phrase used in Chef documentation, in Puppet documentation, in Ansible, in Salt, in Microsoft documentation, the modern ones, the latest ones, because that's the game. When everything becomes definable in software, that you write everything as if it is code. You treat infrastructure as if it is code, and you are able to manipulate your infrastructure as if you are modifying code. And you then treat it like a first-class citizen. Treat your infrastructure just like you treat your code. And that happens, and it is already happened, by the way. When you have modern infrastructure, now I'm not talking about ancient EMC machines. I'm not talking about old Cisco switches. I'm talking about things that are definable through software. Then this game comes into action. Otherwise not. Otherwise it doesn't apply. Otherwise it is still old school. It is unfortunately still old school. If you can deal with it through software, then you can treat your infrastructure as code and make it sit alongside your actual code, the product code, right next to it. In very, very specific terms, all this code, this portion on the left side of this window, what you see is the folder, the directory structure, and this is the infrastructural blueprint. Now let's imagine Michael is developing some application that is deployed on this same platform. That Michael's code that you will see, say Ruby on Rails code, it will be sitting right next to this box, this entire folder structure. This folder structure represents your infrastructure written down as code. Michael's code will be your code written down as code, meaning whatever code is, whatever you create, your app. And then another folder structure that corresponds to documentation of the whole thing. What did you just create? There are parts of documentation here already, like this README file. And these are documentation essentially that do not really correspond to a code, but then some parts of it are actually code. So you see site cookbooks and some cookbooks here. They're pieces of code. Like I just modified one piece of code to build something today. Just one element of code I needed to modify to make sure I understand my customer correctly, and I did that. The line number 15 through 17, I made no changes. But apart from that change, not much change overall. All I did was go to DigitalOcean, create a droplet, got the IP address, gave it to my customer, ask him to map, and come here to my code and make some changes here. And that's my repository change. And I said, go run it. And it actually physically connected to the DigitalOcean droplet and uploaded the entire kitchen, ran the entire recipe set that is constituted in form of cookbooks in that droplet, prepared the infrastructure according to my design point, which is what I defined to begin with, is I want it like this. So I already know my outcome I want, and I told Chef to do it for me, and Chef did it for me, and I'm done. That's what I really mean by infrastructure as code. Do you get that point? Any useful? What makes sense? Do you have things that you want to speak out? Go ahead. Okay, so it resonates. That's good to know. Good to know. So we'll do this. We will give it an hour or so for the name to number mapping to complete. It is not done yet. On the www build something today is not correctly aligning itself to the IP address that I gave. So it will take some time for propagation. So we'll give it until 7 o'clock and we'll revisit this. Until that time, I'm walking away from this activity that I was doing because I can do nothing beyond what I've already done. So I'm exiting out of there, back to my knife solo secret recipe. This is the thing that I wrote. This is the name I chose. What this name kind of indicates is that I'm using Chef solo version, meaning Chef can be used in two different methods. You might have heard from me before. One is it's the solo mode of operation where it runs directly on the machine, the target machine, and finishes off everything it needs to do right there. You need to take your kitchen, upload it to the box, and it takes the kitchen and runs it right there. That's one mode of operation. That's what I just used in this example. Is I ran Chef solo without needing Chef server somewhere away. It is centrally managed. Typically in large corporations, that's what people will use, is manage it centrally. So all your kitchen, all your cookbooks will get uploaded to the Chef server for every project, for every design point that you want. And your outcomes that you will define, my outcome of infrastructure should look like XYZ. You define it in this terms, in specific terms, and that constitutes your package that you give it to your Chef server, and it sits there, and then you operate on your infrastructure. I need this, I need that, create it for me. So it will then interoperate with the Chef server to grab whatever it needs, pull it down, do whatever it takes, and then report back, I'm done. In this example, it may sound seemingly trivial, and yes, it is, but it's equally powerful to accomplish the same thing. So do not think that Chef solo is a second-class citizen. What I'm saying is that Chef solo does not make money for the company. That company that is behind this. So this company, what's his name? This company does not make money on Chef solo. They do make money on services and on Chef server, on their managed Chef server as a service offering. So they do not promote Chef solo. Chef solo is the same thing, the same binary, practically speaking, the same binary as Chef. There's not much difference. You can see the source code if you like. It's equally capable. They just do not promote it too much because it doesn't make sense for them, which is understood. But don't take my word. listen to this company called, who wrote Node.js? Giant. Giant company manages their entire cloud, and this is a cloud provider, by the way. They manage their entire cloud using Chef Solo. Solo, no server. And here is a piece of evidence that will show you what I said. And I'm going to find that evidence for you right now. So we have the chief that manages Giant's infrastructure on YouTube saying out loud that I use Chef Solo for my Giant cloud, whatever. So let's look at that. And so here he is. He is the, what is his name? Ben Rockwood uses Chef Solo to manage Giant Cloud. And let's look at 15:30. At that time, 15 minutes, 30 seconds into it. And watch him.
Really, really simple, right? It goes, it pulls down the my cat client, installs it, sets up a whole directory, injects the solo.rb, downloads SMS manifest, fires it up, and that automatically, when it's injected, automatically starts the check. You know, for the rate. Like, super simple. Which I just did. Totally straightforward.
So you can listen to this. There is a pointer. I'll give it to you. The point being, he uses Chef Solo to manage Giant Cloud. And Giant is a big name player. No doubt about that. Here's the company. And their infrastructure that they provide, it's a public cloud provider like Amazon EC2, like Giant. Maybe not as that big, but still big. And they manage their entire operations using Chef Solo. Pretty powerful. And coming straight from that guy, not from me. Not from me. He said that. So let us, what I want to understand from you is, do you prefer to read, or do you prefer me telling you concepts and then read? What's your preference? I can do both ways. I think what I want to be able to do is understand from you and then do what you want. So yes, there are pages and pages of content that you can read. Chef website is full of documentation, great documentation, by the way, that you can modify because it is open source. You can make changes to the documentation. You can contribute and say something is not right and update the contribution. So here is Chef Solo documentation. You can begin going over that and giving you specific things to look for, and you can go read and do practices on your own, is how I want to start. What do you think? Is that the right approach you want to take? Because I think the best way to read is from documentation, no doubt. So what I want to be able to do is read parts of documentation and then show you examples of how it operates. Is that interesting? Or is that the right direction you want to take? Yeah, a quick walkthrough and then examples, right? That'll help. So I just gave you one big example, which I just ran for you. You just saw that, but that was not very what actually happened. It was almost like something happened, but we don't know what and how. So we got to go deeper now, right? So let's visit the homepage of documentation on the very top level. So we'll give you a structural view as to what documentation they have, and all of it is open source, as you already know. I said that already. From the top level, here's the table of contents. What you have is the workstation. Workstation is that one computer that is probably your laptop. Could be your machine in the cloud that Conrad has set up for himself, that you will set up for yourself. Could be your workstation that I gave you in that memory, so it becomes your workstation. For you, it could be your laptops. It's totally the machine, the one machine that is your workstation. That's what chef workstation in their definition means. It is the workstation where you work. It may be away from you, but that's the workstation. A workstation is a place where you will primarily create whatever you want. That's where you will work. They have this other aspects called a chef server and chef client. Chef client is the binary that they don't describe it here. They're hiding that. It's mentioned here, and they're very sparse on chef solo documentation. Very sparse. But don't get that wrong impression. It is equally powerful. They may be sparse on documentation. They may not want to write about it, but it works. Even if it is not clear in a quick view. So if you try to search for solo, there is a reference here because they cannot not talk about it. They have to. And so there is only a short write-up on how to use Chef Solo. But most of the content and most of the write-ups in the documentation actually is about the two things that I should maybe use this and describe. So Chef has, from a machine perspective, three types of things. You have the workstation that I already said. Workstation. This is the machine you work on. It can be away from you. Then you have two modes of operation. One is a client plus server mode, and the other is solo mode. Two modes of operating, and you saw a quick demo of this. This client is practically the same as this. Some changes, minor changes, practically the same thing. When people mention this Chef server, they're talking about Chef server, not your Unix server, not your Windows server, not your Ubuntu server in DigitalOcean. No, not that. It is the Chef server. So we should qualify it as Chef server and Chef client and Chef solo. When people refer to a server, they actually mean an Ubuntu server or a Windows server or some other operating system server on which you will run Chef client. You get that? The Chef client will run on your servers. And these servers are your Windows and Ubuntu and Linux and God knows what, your droplets or your instances running a variety of operating systems. And this Chef client software runs on the droplets on your servers. So you get that point, right? It is the Chef client or its solo variant, one of these two, will run on your servers. And from an operations perspective, let's say if this is DigitalOcean and this is Amazon EC2, right? You have some boxes here, bad drawings, erase them. So one box here, another box here. These are the boxes that are droplets. These are the boxes that are called instances. Right? So you have two instances here and one instance here. In Chef client and Chef server and sometimes Chef solo, these two elements, one of these two will run on these droplets. Is that clear? And when they run, the process is running here and here, they will interoperate and talk to this guy and get information and continue along running. This Chef server runs only in one place in your company, one. It could be inside your Boeing company or it could be hosted by OpsCode, the company behind Chef. They have a new name called Get Chef now. This company will run this software called Chef server, or you will run it in your company. This is your central point for storing configuration. Anytime these clients running here on these droplets and or boxes and whatever they want, if they want some information, they will grab it from that central location. You will orchestrate the whole game sitting on your workstation. So you will sit here, you here, and you will operate on whatever you want from your workstation. You will invoke certain commands to have Chef Solo run here, Chef Client run here, and they will interoperate with Chef Server as needed. That's the overall architecture. You are completely away from the picture. You're sitting somewhere else. You invoke commands. Like I was sitting right here, and I invoked a command called knife something something, some knife command. And what it did is connected to the DigitalOcean droplet and ran Chef Solo. And since Chef Solo does not have a server, does not need a server, the workstation provides your kitchen. KITCHEN. All the cookbooks and everything you need, you just give it to them at that very moment from the workstation itself. Here, my cookbooks, take it, run it directly from the workstation, as opposed to coming from the server. So in a similar example, from your workstation, if you run Chef, hello, Srinivasa?
Yeah,
Nice meeting you.
yeah,
Hi, come on in. Nilesh, grab a seat. By the way, all these are Boeing employees. They are your buddies.
Yeah, I was going to,
Yeah. Grab a seat. And please tell them where you work, or at least you will know. But even
I've been, I just moved to a new role at Boeing. So I've been working at Airplane Health Center, which is team in the CAS. CAS is a constellation, which is digital aviation. Now we call it changing the name. So the project I was working on until Friday was called Airplane Health Management, which probably heard of that. So it analyzes the live airplane used by airline maintenance used by airlines. It's mostly prognostic and diagnostic. They are also going into the whole group digitalization is going to cloud soon.
Mhm.
But the project I worked before was also a part of the second project for Susan. Also a campus, which is some part of it is in cloud, and not cloud.
Mhm.
They have data which Airbus data they have, so they don't want to be Boeing.
Makes sense. So I think it's a good thing that we are recording the entire session because the session started at 4 o'clock. Yeah, so I'm sorry. I think there was some confusion. The classes here run 4 to 7. And hi, come on in. HR? I do not know. Please ask the front desk. Thank you, no problem. So the class for Boeing employees starts at 4 and finishes at 7. So good that we have recorded it, and I will enable you to watch it, and so you can see the whole thing. I've been talking for last 2 hours, and I expected you, but I think did you speak with somebody? I think today we are speaking first time, right?
I am speaking to you first time until I've seen the video.
Oh, okay.
One of your videos from
Okay. Okay.
I spoke to someone at the Lake Washington.
Marsha.
Right. So I remember she mentioned 48, but then when I signed up, it was 6 to 9.
Yeah, the computers.
Somewhere it was 4 to 7. Somewhere I saw one place, but when I spoke to her, probably she told me 6 to 9. And
Ouch.
the registration.
Ouch. So I'm sorry.
No, not you.
I'm sorry. It is my fault. At the end of the day, it is my fault. I'm sorry. It is 4 to 7. I hope you can still make it. Thank you.
4 to 7 on Monday.
And Wednesday.
4 to 7 on Wednesday.
4 to 7 Monday, 4 to 7 Wednesday, and keep going until December 1. It's 2 more months, right? The class has been running for about a month now.
all the time for 7 hours.
Yes.
Okay.
So the class, it's, I think you just started the second segment and the third segment. Is that the idea that you want to do? But we'll discuss that. So the idea is there are three segments. We have finished one segment the last time we met. Today is the start of a new segment. We just started. Yeah, we just started, and I understand that you will discuss what. But yes, we have it recorded, and we'll give you a login, a school password, and school account. You understand what I'm saying?
Yes.
School login, school password.
Yes. I think I got the email.
I see. Okay, yes, that's a good one. If you got an email account, that's good. But that's not what I'm talking about.
On the clock. Okay.
Yeah. So what? So I think let's continue the conversation I was having. But let me tell you that you will get another email address from me, and that is what you will use to access the recording. And I will create that account for you before you go at about 7:05, 7:10, 7:10. At that time, I'll create for you right here. Okay. So hang on tight, and let's continue along. Uh, so what I was saying is, if you are sitting on your workstation, that's where I was. Yes. So I completely lost my train of thought. But no worries. No, I am sorry. I should have somehow managed to tell you that the class starts at 4, not 6, and it is my problem, nobody else's problem. But first day should be the right one, and I am being, I should have found a method of reaching out to you. I did not have any method, by the way. I just heard your name like a few days ago. And I should have found a method to reach out to you to tell you the class starts at 4, not 6, even though whatever else may be saying something different. So it is my mistake. Sorry. So you sit on your workstation, and if you're going to use Chef Solo, then this Chef server doesn't come into picture at all. You will use Chef Solo, and you will invoke it to a DigitalOcean droplet or a Amazon EC2 box instance, and you will run this binary, and you will provide your cookbooks and your kitchen right in that box, and it runs all here with your input. You saw uploading my kitchen briefly a few minutes ago. So that went through, and the Chef Solo binary runs. There is no Chef server, so there is no such thing to go to. You don't need it. You saw this guy. Where is this guy? That guy was Ben Rockwood. You saw Ben Rockwood's example, a few minutes of video. He said he uses Chef Solo for joint cloud across the board, and he does not need a Chef server. That was clear. A similar example when you are using your workstation and you have your cookbooks and your kitchen and everything, but you give that kitchen to your Chef server. So you put this kitchen here in Chef server, and when you invoke a command to run on your droplet in the DigitalOcean or your EC2 instance, somewhere here, EC2, at that moment you're running Chef client, and the Chef client run essentially starts here. And since you told it to run Chef client, not Solo, you are essentially asking client to look up to server for information it needs and get it back down. So the information exchange happens between server and client, not from your workstation. So even if your workstation goes away out of the internet, it still will be able to operate based on the connectivity between server and client. In the case of Solo, you need that connectivity for the kitchen to be uploaded, right? Question?
Yeah, I look at Chef server. I think there's some benefit in terms of being managed.
Yeah, there are pros and cons. There are pros and cons. But the point being, you can pull off a big operation just with Solo also. It's like whether you like Pepsi or Coke. There are some pros and cons, but not much. Yes, in this case, it's not as simple or comparable as Pepsi and Coke versus Chef Solo and Chef Client. There are some benefits, no doubt. But there's some cost also. Like you have to now worry about the upkeep and maintenance of the Chef server, or you have to pay somebody to do that for you. One of these things. So that aspect comes into play. Yes, there are benefits. There are some benefits of having a Chef server, but Chef Solo alone is not bad. That's the only summary I want to say. It's not bad. Don't discount it. There are cases where it can be used. So keep that in mind. Keep that in mind. Now, when you saw the run happen, what you also noticed from a raw DigitalOcean droplet or the box that we had with Ubuntu running, all it had was just enough operating system, nothing else. It did not even have Chef. You notice that, right? So the first thing it did was to install Chef on the box right here. So now it is not just enough OS, it's something more than that. So it begins with Chef installation, and then whether you're solo or not, whether you're Chef Solo or Chef Client, depending on the choice you made, it will then operate the next step, which is then reach out to the server and ask for, what do I want to be when I grow up? That's the fundamental question. It's a biologically incorrect analogy I occasionally give. You remember that, right? What I say is, so the class has been going on for like about a month or so. So they already know me. I know them. So we've been talking. But you are so you hope it'll probably sound strange to you. I'm like already talking about, but we'll talk more, and I'll bring you up to speed and make sure that you understand what I'm saying. So the the idea being, this is not a just enough OS anymore. It needs to take on a role. Take on a role in that example I just showed you about was, the role was that's the role I wanted it to take. Not just Linux, but also add these elements. And not only that, also add a root password to it. And then once I had that defined already in my cookbook, I had defined my root password. And then I was able to log into MySQL using root. And then I created a user and a password and a database. And then I use that information to give it to my software that I want to run. And then I have the software running. I hope it runs. Let's see if it runs. No, not yet. But yeah, it'll run. Don't worry. At some point, it will update. So that gives you a initial kickstart as to what how things actually start rolling, right? Now, the company behind this thing, Chef, which is Opscode, provides you binaries to install it wherever you want. And you can very easily go to that site and say, download Chef. And that'll bring up right there. They'll give you download links, and you can install it wherever you like. You want to install server, then you go this route. Development kit, I don't think we want that right now, but that's this route. You can get Chef Client, which is what exactly I think you want. And you click, and it will give you further choices, like what choices you want, which operating system you want to install. And you can select I want to have Ubuntu there. And then I want to select a version, say 14.04 version, and select an architecture of 64-bit. And here is the command I want to run on my client. Oh, sorry, on my droplet, on my instance. I should not call it a client. But this is Chef Client, by the way. This is Chef Client that will get installed on the remote droplet in the cloud, or on the EC2 instance in Amazon Cloud, or DigitalOcean Droplet, or God knows any provider. It doesn't even matter. So you can further refine and select your Chef versions if you like. Here. I think the latest ones are good. There's nothing wrong with them. So you can grab the latest top of the, whatever comes out from the biggest number is good. So 11, 16, 2-1. Yeah, you can just download a deb file if you like from here and install it manually if you want. But this script will exactly do that for you. So you run this, copy this, and go to your DigitalOcean like this. And on that location, once you connect, you clear, check your machine, which machine are you, and yes, you're on the build something today server, and you can just paste that link and run it, and it'll install Chef, as simple as that. It'll reinstall Chef right now. It'll overwrite the previous Chef installation and reinstalling Chef. It finished, done. That's pretty much it. That's what you saw doing on its own when I invoked it remotely, but this time I am running on that computer directly. You familiar with what I'm talking about, like SSH access and things like that? Are you comfortable with that?
Okay, yeah, sure. So last year in the beginning of the year, I've done a boot up Amazon database.
So, okay, so you
They did cover check mark and all that.
Did-
briefly mentioned, they did not cover.
I see.
They briefly mentioned about it, but they did not cover.
Okay.
So that's the reason I couldn't sign up for the first one. The first,
Could not.
no, yes.
Right. But could not. Why could not?
Oh, why they did not
No,
cover?
no. I heard you say that's the reason why you could not sign up for the first month.
Oh, well, I did not say no. I did not.
Okay, could not. Did not. Did not is fine. Yeah, did not is fine. Could not was a problem, sir.
Yeah, so I know little bit check mark, look at the operation, deployment and I learned.
Sweet.
So you install check about the remote here.
No. You do not install Chef server at all unless you really want to. You don't install Chef server at all unless you really want to. If yes, client does all the grunt work. It is the work of Chef client. Chef server does pretty much nothing except, okay, here it is. Here is the thing you need. Give me your information. I'll store it. Here is my cookbook. Take it. That's it. Or maybe some reporting. That's pretty much the role is. Server can be, you can run like manage 10,000 machines on one server comfortably on a decent sized machine, of course, but comfortably do it because server doesn't have to do much. Client is the workhorse that runs and goes on every damn machine that on the wherever you have, like DigitalOcean, EC2, Rackspace, HP Cloud, wherever you get machines. Client will do the horse like a workhorse. The real worker is the client, which runs on your servers wherever they are. But no, you're not setting up Chef server unless you really want to. Yes. If you remember that, I began looking at the downloads website. Let me track back. So see, I went to I searched for download Chef. Then I went here. Then I looked at things available here. And I looked at Chef server and I said, no, I don't want that. I don't want development kit either. I want Chef client. That's what I want. I want to get client, not server. And then I selected the operating system, which happens to be Ubuntu, and the version and an architecture. And here is my command. So it's the client that I'm running on my remote box, right? And you can even go choose a specific version if you like and download Debian file if you want, but that's not what we're doing. We're using the command here, right? And we are installing, and we did install, manually install Chef client. Now, when you actually go about using it, you don't even install Chef client like this. What you do is what I just did a few minutes ago before you came, which is I invoked Chef through knife as a remote control tool. So you invoke against an endpoint or a target box in the cloud, an EC2 instance or DigitalOcean droplet. You operate on it remotely through knife command, and all you did was this, clear, and the command I ran was what? This is the command I ran. It says knife solo bootstrap, and then a user and IP address. So it essentially is a combination command of two things: preparation and setup. So the if you look at the command itself, knife solo, and press enter, it will tell you subcommands: knife solo bootstrap, knife solo clean, knife solo cook, knife solo init, and knife solo prepare. So bootstrap is a combination of prepare and cook. Prepare will set up chef. Cook will cook your cookbooks. How crazy that. So bootstrap is a combination of prepare followed by cook. Remote control. So it's basically something like you ask knife to connect remotely to a remote computer and do preparation. Preparation meaning prepare that JEOS, just enough operating system machine, that tiny little machine you get from Amazon EC2 with nothing in it, just the operating system, to prepare that machine to run chef, which means install chef. That's it, nothing much. A part of chef. Knife is part of chef. It's a part of the tool for the chef. There's some terminology here, but knife and cookbooks and recipe and kitchen and God knows what. So there are more, but right now this is knife solo prepare. Will just prepare that box that you just got. Install chef, hook up. If you're using a server, give it the address. Okay, here is my server, so please remember, and please install chef on your machine on yourself. So it installs chef, and then it is done, the preparation part. The next command will be cook, meaning now I need the cookbooks. So once it is prepared already, I need to either provide cookbooks through chef solo operation by uploading the kitchen, or if it is chef client operation, then I need to tell, please go to the chef server, grab your cookbooks and run it yourself. So it will go to the chef server, grab the cookbooks and run the cookbooks themselves to finish off the operation needed to make it happen, which is to produce the outcome which I designed at my workstation. My workstation is not even in the picture. All I'm doing is issuing a command: knife, go do this. Knife, go cook. Or knife, go bootstrap. It's a combination command. It does the whole thing in one shot. Knife, cook, bootstrap. Actually, so hold on. The command was knife solo bootstrap, not knife cook bootstrap. Now, in this case, I'm using knife solo, which is a part of chef solo, so the server doesn't come into play. But if you're using a server, then the command will be slightly different. It'll be knife bootstrap, and this word solo will not be used at all. The command, every other command is exactly the same, except the use of the word solo in middle. So that red item will not be there. The actual command will be knife bootstrap as opposed to knife solo bootstrap. That's the only difference from an operations perspective. I'll tell you that. I think it's good to clarify. So chef runs in two ways. One and two. One mode of operation is called the solo operation. It does not need no server. The other mode of operation, it runs as client plus server. Get that? So when I'm using the solo command, there is no server needed, and there is no chef client either. It is the solo binary, which is very similar to the client binary, but it is called solo binary. You know, binary is the package that runs. It is different from the chef client binary. This client binary is different. Binary different, conceptually the same. So when you say chef client, you actually mean this. When you say chef solo, you actually mean this, and you do not mean chef client. It is conceptually the same thing. And yes, it is a client, but it is not the chef client because it's a different binary. Three binaries. One is this, and this is the third one. And you can see them downloadable from here. See the chef server binary, chef client binary, and open source chef server 11. So this is similar to that one. This is version 12. This is 11. Same thing again. Okay, lots of people using it now. Great. So that's awesome. Actually, they have been able to. I know they have been using it forever, but now they are publicly coming out clean, that saying that yes, we are using it. That's the big thing. Endorsement. Endorsement is powerful. I know Facebook has been using this for years since I started using it. So, but endorsements are powerful. So you have to do you have to for measurements and metrics you have to do it another way. Yeah, some metrics that chef server does are not available to you because you just lost out on that part. So it's a fair game. A very good question. Yes, you lose. Yeah, it's not exactly identical, but for all practical purposes, if you want to not go the route of taking a dependency, and if you want to purely remain open source, and you want to keep everything in your control and not depend on that chef company, you can do that. If you have people in your company that can manage open source projects for you, you grab your GitHub repository from Chef, from GitHub, clone the whole thing, bring it internally, and you put a timestamp. Okay, that's my timestamp. I will now make changes from here on beyond. I will retain control and I will manipulate whatever I want. I know what I'm dealing with, and I don't need to know anybody else on the planet Earth. I can manage this. So when you have that ability to do it, and you really don't need anybody else on the planet Earth, you can even go to the extent of getting client and server both internally in control and still run it. Still use Chef server, which is also open source. You just saw that. Even now, sorry, even 12, even 12 is open source. I think so. I can confirm that. It did not say that, but I can confirm. Yeah, I can confirm. You go to GitHub and you will find it there. If it is not published on this website, they're obliged to publish it on GitHub by license. It is open source. By license, if you work on something, you have to tell it to the world that we did it. If you're selling it and not giving it, that's bad. It is open source. You have to give it. So on GitHub, you will find it. 12 also, and even 13 if it's coming out. Whatever branches and builds you're developing, you will see the whole thing there. Even if it is not publicly released, it's still being visible publicly on GitHub. So yes, you can take control and still have server in client both in your control without depending on any company, or use the solo part and still not depend on anybody else, or the third route, which is go depend on them, pay them money and use them. All these jobs, all these options are available for you. It's your choice. It's your choice.
So the service part, paying part is more for the service support.
Service and support, primarily support. Yeah, and some backend and the redundancy they provide you with resiliency. They provide you multi-tenancy on Chef server itself. So I will have an account with ops code on their Chef server, and you will also have an account, and these accounts will be kept separate. And all the same concept will apply, and you can use their services. And yes, they are the creators, so they know what they're doing, and you can trust them. No doubt about that. Yes, they're trustable people. They created it, so you can trust them, and you can take that service and use them. But you don't have to. You can. Cool. Do you want to run something on Chef Solo yourself? Let me bring up an exercise. Machines. Do you have a machine in the cloud that you can connect to right now? No? Is a Boeing laptop? Okay. Do you have putty?
I have
Do you have proxy? Fox? Socks proxy? SOCKS proxy? Okay, good. Yeah, connect to a remote computer. Do you have Amazon account?
I have it.
Go, start a machine. Yeah, small machine,
Like
small, medium size. Medium or small. Is it your account? You pay for it or Boeing pays?
no, going. I mean, I had a free. No, going there.
Boeing doesn't pay. Oh, let me tell you, Boeing pays. So they will give you an account. So next time, I don't know. Yeah, it's all Boeing. So I'm just treating you all brothers and sisters. But apparently you have an account that you can share. I don't know. You decide. I just made, probably I spoke too much. But if you don't have an account, then you don't get it, but you get the free version. But you have another person in the class that can give you an access. Since you're a Boeing employee, I think he'll give you access. It's not a big deal for him and not a big deal for Boeing at all. You're learning. So what's the point? Take it from him. He'll give it to you.
Create a free account. I mean,
Yeah, they give you free for 1 year.
they
True. Yes, yes, true, true. So do that and start a machine, make it run Ubuntu, and this all in the family. So it's all Boeing. They should be able to give it to you. There's no issue there. At least I don't see an issue. Yeah, you took a free version, but he gave it to you, right? He said he's going to give to everybody in the class. Yeah, he'll give it. Yeah, you did not take it as a different thing. Conrad is ready to give it to you. If you are a Boeing employee, I don't think he has a problem. He'll be next time. I think he's going to. He was running late today for some meeting he had. Oh, he's a student. Yeah, yeah. Yeah, you'll like Heroku, man. It is still stuck with Heroku. Can I check your entries?
The first time I set it, it takes only 2 minutes, but that's because of new domain.
The C name Heroku. So give it a few minutes. I think it'll change. It'll work. So the exercise I want to go do like this is where is that exercise? Hands on. Yeah, that one. So what this does, this Chef Solo. Yeah. Yeah. So do you let me before I run these commands for you. I want to make sure that you are able to run it even if you don't have virtual machine. So that's what I'm trying to set up for you. Because these instructions are written down for the virtual machine to be used. And you cannot use virtual machine on that laptop. Okay, do you have a personal machine?
Yeah.
That's okay. Do you have a Mac or Windows? Okay, fine. So I will give you a virtual machine, no, virtual box. You know virtual box? Have you heard of the name? Okay. Mhm. This is a virtualization software that will give you a machine on top of real machine, a virtual machine on top of real computer, and then I'll give you a machine to put in the box, and then you will run it. Yes, yes. This machine will not allow you to install, but the other one will. So in this sequence of steps that I have here, the goal of this exercise is to first get you to run Chef Solo on your own. Second is to demonstrate some ability of self-correction or self-healing that Chef provides. The idea would be that you take a sample cookbook that we have here, install something, and then destroy it, and run it again and see it correcting itself. That's the idea. So in order to run this, since none of you have a virtual machine right now, I will have to walk you through how to get it on your specific environments. So two of you who have a remote access to a computer in the Amazon cloud, I would suggest that you please putty connect to them, connect to the machine in the cloud. Even if it is bare bones with nothing else, just Ubuntu, that's okay. But please connect that. And for the other two, you have Macintoshes and you have Ruby, right? And you have Ruby version, please. 2.1, or what you 2.1 something. If you have a DigitalOcean account, just remotely connect to it and run it right there. So make sure you have a terminal connection to some machine somewhere, or run it locally. One of the two. I think it is best run away from a Mac. You can run it on your Mac, but I don't want to destroy it, honestly. So, you know, classroom software should not be run on production machines. These are production machines, right? We're going to experiment. We'll make mistakes. So I don't want to run out or ruin your machines, your personal laptops. Not no bad idea. So I would not want to do that. I would suggest you remotely hook up somewhere to a Linux computer, SSH access, a PuTTY access. Yeah, to take Ubuntu 14, no, stick to 64-bit, of course. And that's there is a quick start. Begin with quick start. Don't go community. Yeah, here select this.
Is that okay?
Yeah. Select the free tier. Take the free. Excuse me. Take the free one. Take the free one, and you have a free account. Use it and connect to it. Connect to a free computer. Use PuTTY to connect to your remote instance. So configuration instances, get a public IP address. So here you have to say auto assign public. No, it's okay. Drop down here and select enable auto assign public IP, and then your most of it is good. So the review and launch. Do you have a key?
Should be.
It's okay. Good. Next. You're open. Port number 22. Is that open?
Next
Security group. Okay. 22 is open. Yes. Go review and launch. Give it a key and connect. You have key?
many keys.
So you create one more key. Yeah. And hook up to it and remote connection. And then we'll begin installing and see what we have. So the first step we have is so here is a sample repository that I provide, this one, because it is private and I have to make it available to you. So it's there. So if I go to that link myself, it will open up, but not for you because it's logged out. So I'll enable it for you, and then you can use it. It's private. Huh? Okay. Yeah, this is a paid account, and so I'm going to open it up for access to you guys. Collaborate, password, and add the team, Big B team, and add the team. Hey Sama, what is your name? I'm not Sir, I'm Nilesh. Srini. So what is your GitHub login name? Don't call me Sir, please. I'm not a professor. Do you know that?
Oh,
Do you know that I'm not a professor?
I went through your profile. So,
Good. So I'm not a professor. I'm a dude.
yeah.
I need your GitHub login name. If you have one, please give it to me. GitHub. create create one. Sorry. Yeah, I shouldn't be eating that. That's unproductive. No, it's not highly spicy, and it is unproductive, according to my definition. Yeah. See, I told you I'll cough, and that's going to be bad, but I think it is so tasty that I cannot stop it. So I think I enabled you access. I'm just waiting for Srini. So you should be able to see that repository again. Did I add collaborators, Big B, add team, team not found? What do you mean not found? Big B, add team. What does it mean? Huh? Hey, can you please check, Michael, if you have access? You do. That's good. But then I don't know why it's not saying you don't have access. Oh, it is. You have it. You have it. So only thing I'm waiting for is Srini. I need you to please create an account for GitHub and then give me the login name so I can add you to the team. And please do not run it on your local machines. I don't want them destroyed. Worked? Yeah. Yeah. Destroy DigitalOcean all day long. I don't care. You have $10 coupon there, right? Yeah, sweet. All free. Free is good. Did you find the link where the write-up is? You did, but did everybody else did? Maybe I should give that also. Yeah, so here is a write-up. You can search it on the library site. Look for the heading here and search it in the library, and you should be able to get going. In the meanwhile, I'll go and help Trini with.
Yeah, I have it.
You do?
Yeah.
Good.
I just signed up.
Summer home.
Yeah, it's a free one. So that's enough.
Free is good. Free is always good, by the way. Free is the best. So what is the? I want to see the spelling. SAMAHOME.
HOME,
That's it. Eight characters. Where are you from? Hyderabad. I can tell. I can tell by your accent. Yeah, really. Wow. Thank you. You're talking about me on the weekend. That's something is wrong. I can. I understand. Yes, I understand. This is my third career as a business person. Thank you, sir. Yeah, 10 years. First 10 years. The next 10 years at Microsoft. Yep. Thank you. Whatever. I work hard. That's what I know. I really work hard.
I'm sure. So
Connect to it.
yeah.
Putty. Yeah, use the key to connect to Putty. No Putty Gen. You need to first convert that PEM file into a PPK file. So you convert that first, and then you can use Putty to connect. I'm from Madhya Pradesh, Bhopal. Let me give the link here so you can access it. Okay. In the link I'm going to talk about is this link, and that's what I'm going to take and put it in the Big B location here. Okay, there it goes. So you have it. So that's the write-up we are trying to follow along as we go through this exercise. This link. We just updated the link. So you should see it in your classroom.google.com. That link is now available, and you should be able to access it. This one, and you convert into PPK, and then so you load it first, load the private key, and then you save as PPK. Use the right key. You may have lots of keys.
Yeah.
Use the right one. So to get the write up here will say install Git, and it's a, and so it walk you step by step how to proceed. Yeah, the write up will walk you through step by step what it takes to build up the machine to even run Chef. And the first step is, of course, install Git. The write-up talks about some virtual machine that you don't have. Actually, now you do. You have a virtual machine in the Amazon cloud as opposed to here, or DigitalOcean cloud as opposed to here. And yes, you do. So you got your PPK?
Yeah. So generating one.
No, you're not generating one. If you generate one, then you cannot connect to it. Right? You have to load it, not generate. You have to load your PPK in putty, and you load it, and then save as. That's it. One key.pem, open, and save as. Save private and public both. You can save both one at a time. So save the public key, call it one key.pub, save, and then save private key without a passphrase, yes, and save as one key.ppk and save. And then you exit. Then you have the PPK file. Then you start putty. And in here, you type your IP address for the Amazon computer, and then you give your public IP. From there, give your PPK and login. Public IP. Then you go your SSH auth. In there, you browse the private key PPK file. That's it. And then you go change a couple more things. SSH. Somewhere in here, you have to put the login name, which I think is root, or maybe Ubuntu. So click data. Auto login username here is Ubuntu.
Oh. Is that the default? Or?
Not the default. It's the default for Amazon. Now you have to go back to the sessions on top and save that. Give it a name. Call it Summer Home or whatever you want. And then save. And then open. Just open. It'll open. And say yes. And there it is. There you connected. You're done. Now proceed. So you follow along these steps. Now how do you get these steps? You cannot go there yet because you're not a student yet. So now let me make you a student account. Okay. So I will do that right now. And what do you want the login name to be? Summer Home. I can you choose your login name. Summer Home. I'll tell you some brief background. The background is that this is the Lake Washington Institute of Technology. I am not an employee. Okay. I run my business. This is my business. And in that business, I have students in multiple locations, like you see in this corner. And in the Seattle location, I have these students right now that are sitting here, except you. And so I'm going to add a new student. And I'll say Srinivasa, correct? It does matter, sir. How about that? Is it correct now? So the Sama Home is the login name you want, and your password is Cloud Genius. One word. And give me additional information like your address, your email address, and phone number. 1664 Oh, not that address. I want.
How the email address?
Oh, you will give me physical address. I do not need that.
Yeah,
Just email address
email.
and your phone number, please.
919-807-425.
Got that? Is it correct? No, no. Less is more. Just less. The only thing I can get away with is good. So what I'm going to do now is to say welcome, oh, sorry, Sama home at gmail.com, and I'm going to invite you and tell you your login name and password. Your password is Cloud Genius. Your email address is this, and you can sign in services at email.cloudgenius and see the class at here. So that's the email I'm sending you. Please check your Gmail for instructions. And what I just did is created a student account for you. This is what I mean by student account. It goes to this domain called Cloud Genius, which is my business. And this is one class. This is the other class that I have, and a third class in Expedia. And so that's what I'm currently doing in this region. I have other locations, like the location in Chicago area where a professor teaches, and this is the video you probably saw.
Yes,
Okay, good. So we now have a student account for you. It looks like Gmail when you log in, and I would like you to follow through that and establish a student account for you so that you can then see what the class is doing. You will also see this site here called classroom.google.com. And in that site, once you log in, then you type in this code number that will let you into the classroom. And then you can participate with the class, whatever they're sharing, discussing, emailing, I post, they post. And we are recording this talk right now. The screen that you see here is broadcasted on the internet. So even if you're not in the room, you can watch it. And whenever I stop talking, then it becomes a YouTube video, and it becomes available to you if you want to watch it again. No, no, no. No. I, I have not decided to make it public yet. I might, I don't know yet. But no, right now it is not public. It is just for this room, just for this class. And so you want to check your Gmail that I sent, and then it will create a new login email address for you, which is samahome at CloudGenius. That's my site. Yes. Yes.
so that's when I click on that link.
It goes to Gmail, right?
My Gmail.
Correct. So you need to log out of Gmail and log into my site, and then it works because it's a proxy. It's a Gmail. So here, now you click there. So click here and say sign out, and here say add account. And here you say instead of gmail.com, you say cloudgenius.us, and password is cloudgenius, one word, and sign in and agree and accept and all that thing. So you want to agree, accept all the services, to create a new password for you, and this looks like Gmail, works like Gmail, everything is like Gmail, but exactly, it's cloud, the Google Cloud for work, the Google Apps for work subscription that I have taken. Yes, and I use that to do the things that I have, like students can access, and you can keep your account secure, and yeah, you can use whatever whatever your phone number is. Just type that. It doesn't have to match that. Doesn't have to match that. No, this is not the code. This is your phone number. This is a different website. It's called classroom.google.com. It's a new service for schools. It's like Facebook, but for the classroom. And you can use the same login on your phone. So the same, yeah, it's full Google services, all of Google services available for you. And pretty soon, unlimited storage. Yes, pretty soon, coming up. They announced it. Unlimited storage. No kidding. Yeah. Mhm. Where was the failure? I want to see that failure. Oh, that is the GitHub login name. GitHub login failed.
Yeah, I try it. Oh, but I try it.
Your username is wrong. It is not this user. This is VM, the Cloud Genius VM.
Oh,
That's GitHub login name.
so when I try my GitHub login name,
Uh-huh. Yeah, that one. Yes.
right? Or maybe I used the wrong password. Keep trying.
Let me check that. Hold on. Oh, are you neighbors in the office?
So I moved to a new team.
Okay, thank goodness. Yeah. Now, it might happen that your neighbors next door and you still don't know. Yes. Got it?
I can kill it and all that. So
You cannot do that. You have to go to that machine there in the Amazon cloud. It is not local host anymore. You have to go open up HTTP.
so this is my, I'm doing it on my box and digital ocean.
So yeah, go open that IP address on the browser.
Tried that. It's not working.
It will not show you anything because there is nothing in it. So try the IP address, DigitalOcean IP address.
I tried that. It's not.
What did it say?
This
Yes, yes.
I did that.
It will not be able to connect because ports may not be open or the Apache process is not running or unable to connect. That's fair. So check your machine whether it is actually running Apache there locally on that computer. It is not running. Not running. Right now it is not running.
How do you know it's not running?
Because otherwise it will show you a listing of things running. Right now it does not say anything about Apache.
Okay. So, how do I run it?
So roll back to your documentation and see where we are. You killed it already.
No,
So,
I didn't kill it actually. I just ran
so
this command.
scroll up a little bit, a few more steps, and check you ran this command here.
Yeah.
Or so run it again. I want to see it. I want to run the whole command running. Yes, no command not found. Yeah, I want to see this. It did not run Chef Solo. That's why it is not running, and that's why Apache is also not running. I think this exercise is meant to be running in a virtual machine. It is not designed to run without without that. So I have to hack around it to make it run there. That's what I'm doing right now, which is fine.
Oh, I should have installed that.
It did not install Chef. It did not install Chef, so it's not running Chef. Now it installed Chef,
There was a command which said that it will install.
but it
Chef
did not.
and
Yeah,
Okay.
it should, but it did not, and and therefore it did not work.
Okay.
So now you should see. Where is that command itself? Let's open it in GitHub. Do we have a GitHub here somewhere? No.
GitHub, no.
Done?
Oh, I just got kind
Oh, you got signed in here.
the
Okay. So Big B is the team name.
Uh-huh.
Your team is Big B. And here you can see the stream.
not the tall B.
This is failing to install Chef, apparently. That's what happened on that machine because it is designed to run in a VM, not in the, so I have some assumptions made in the VM. So the repository that you cloned from GitHub assumes that. That doesn't hold true in the DigitalOcean droplet. The workaround is to install Chef by sudo apt-get install. And then read, I'm going to go to the big screen and show you what's going on. So here's what's going on. Huh? Okay. So if you look at this repository itself in GitHub, you will find that it's actually running this command here, which basically goes out and deploys Ruby and Rails, which is not needed. That's why I said do not try it on your real machine, it will destroy it. You don't want to run these things on your real computer at all. They won't even work. The sudo apt-get will not work. And it installs Ruby 191. You already have a Ruby. You don't want that. So that's why keep it separate. It's good. And this exercise specifically says, install all these things like Ruby 191 full, then knife EC2. And at the end of that assumption that you run Chef Solo by typing this command, the last line, which is line number 15. If you just take that last line and run it locally on that remote computer, that should work, provided your Chef binary value is corrected. The Chef binary value is that one, which may not be. So that is the root of the problem here. At the top it says Chef binary, the variable value, which assumes that you have home, user, RB, ENB. These things are not installed in your remote computers. The virtual machine has it. So the variable defined in line number 2 does not hold good anymore to begin with. So the whole thing falls apart in a remote computer, because in the virtual machine you have Ruby, RB, ENV defined. You have a user called user. You have a home folder, and RB, ENV shim with Chef location is predefined, and that is being assumed in this command. That's the reason it is breaking. It's totally fine. It's supposed to break because it is not designed for that remote environment. So what I will now do is create a new script for you. And the script will be very simple this time. And that will look something like this. Yes, you did. You would. And I'll modify this script itself to make it work on your computers in a different fashion. This is what I will do. So the line number 1 is okay. Line number 2 is bad. It doesn't apply. So we are striking it out like this. Then line number 4 says, are we on a vanilla system? Yes, we are. And we check for Chef binary is already installed or not, which is line number 5. And then export a variable non-interactive. 7 and 8 are dummy. 9, 10, and 11 will install certain things. I will add one more, which is Yes, and because of this software, that is also nice. It is very nice. Yes, indeed. I like it very much. So I am going to say that we simplify our command structure by executing only these commands on the remote computer. Some of it have already been done, and then the last command will be this. That's what I want to run on the remote computer in the cloud, which these steps will fit into our scenario. Your basic install steps, and then repeat line number 8 over and over and over again. As we say, run it again, line number 8 should run it. In the instruction, it says, run chef solo again. That's the line number 8. All other commands are one time. I want to check line number 6 for accuracy. I did not check. Can you check, please, if 6 is accurate?
It's not meant for me, right? Like for us, we are running.
Yes, it is meant for you.
Oh, really?
This,
Okay,
yes, you can just follow along step by step. One,
type and explain.
yeah, exactly. One by one line at a time.
Oh, just do
Yeah,
outside of
exactly. You can just copy and manually type it. Sudo apt-get update and apt-get install git core.
So I'm getting a gig.
Yeah, git dash core, yes. Git. Michael, when you're at the moment, check line number 6 for accuracy. See if it works. It should work, I think. I may need to modify 6 to say chef or chef client, but I'm forgetting what the exact terminology should be. Probably it is just chef, depending on the package naming. So you just finished the one step. I would like you, Sama, to go back to the write-up and grab the Git repository. The write-up says grab Git repository. I see. I would like you to grab the write-up because it will give you the. It's in the very top link. The very top, there is a pointer to it. So here is the write-up, and in the line number, one of those lines, there is a link to GitHub. Yes, chef. So that should change in line number 6. Yeah, you need access. Let me give you access. You have lots of access permissions. You're new, so. Right. We've been using this for about a month. We started a month ago, and we have been going along, learning things and stuff. So let me give you access permissions. Where is the access kept? Groups. I think it's in groups. Big B. You should be a member of Big B, and that's what's preventing you from accessing it. Where is Big B? And where is my internet? Okay, there it is. Groups. Big B. Manage users. And add users. Yep, you should have permission now. Yeah, and I'll help you with that. Oh, sorry. Command number 6 was wrong. This should be like this. That's what Michael just found out. I typed these commands without even checking anything. I just so. Yeah, git core is installed, so you should clone the repository, which is git clone, and then the link. the same link, and you need to give your GitHub login name and password because it is secured repository. So it is private only for the class. I mean, most my repositories are private for the class because I don't want to get them public. I think Michael is doing it fine. Yeah, it's working for Michael. It is fatal because it is not found because did you type the password correctly? Can you open the
So that's the password for my GitHub.
Your U is uppercase. Was it?
So here you know here.
Here it should be uppercase and there is a typing mistake here.
Oh, I see.
Check that. I'll go fix the typing mistake. This U, using U, no, not that, this using U. Sorry. Oh, you're such a keyboard junkie, man. Yes, make capital and see if it works. Not found, repository not found. So take that link, open in a browser and see if you're able to log in and see it visually. Michael got it to work. Awesome. So open in browser, enter, and see if it opens up GitHub. Page not found. So try login to GitHub. Oh, you need to do one more thing, which is you need to become a member of the GitHub group. So I have sent you an email on your GitHub email. So check that email and say, yes, I agree and accept. Otherwise, you are still out of the group. So you have to accept your membership. And when you do, I think you should be able to on the phone. Just click, it should allow you. You can, by the way, switch accounts like this in the little triangle here. It will let you switch back to your personal email and so say add account and keep going. And you add other accounts and log in, and that gives you a personal account. And so you can just switch dynamically like that. Yeah. So I invited you to GitHub membership. So big, click on all of these and verify everything for GitHub. Otherwise, it will not let you in. So click on that link, verify. Next email, follow through the instructions they'll tell you, and say confirm. Then go back on that email and follow through all the steps they want you to do. And so go next one, invited you to do what? Join the Big B group. Okay, say yes, I want to join, and say join, click, and then you back to your terminal. It will now let you download clone. Yeah, here it will let you do that. Enter. Now it will allow you, say repository found this time. Otherwise it was not found. So it got the repository now. Now you continue along.
What are we doing here? Like we installed it in the previous command. So get the clone the
So I'll tell. I think you're probably new to you're new to Git.
Yeah. Right.
So yeah, we just finished a few exercises on Git. So no, yeah, last time, but we did. So I'll tell you. Git is basically, think of it as a box. Git is a box, and Git software is the box itself. And then whatever you put inside the box is called Git repository. Okay, the thing inside the box is a repository. Git is the software. It lets you manage whatever you put inside the box. That's a simple definition. Very, very simple definition. You get the concept, right? Git is the software. It's a box. Yeah. Yeah. It manages the content you put inside the box. It's not. Git is not a build system. No. Git is a source control system. You can use Git in part of a build system, but Git is a source code control system. No. Ant and Maven are build systems in Java. Yeah. Git is source control. CNAME to another name or CNAME to an IP address. CNAME doesn't IP address. CNAME is a name to name mapping. It's like Michael to Mike or Mike to Michael, not Michael to social security number. A record is what you want. So A record is like Michael and social security number. Oh, you got it. You should show it to everybody there.
Oh, no, that's not mine, that's yours.
I know. So you should show it there on so everybody can see the build the thing. It worked finally. So you come here and show it to everybody in the class. Why sit alone, man? It is yours. Build something today. See that? It worked. What were we trying in the first few minutes? It worked finally. And so I can continue along. And it says you need the database name, username, password, host name. So I say, let's go. I have it all. So what is my username? I don't remember. So I'll go and read here. Okay, move. What is this thing?
Oh, sorry.
Oh, you projected.
I was
Aha.
thinking then you, okay.
Aha, you go ahead. I think let me
I thought you
yeah.
wanted me to check.
Yeah, I do, but then you know what? You don't have the password.
Yeah.
So let me do it. So I'm going to stop your projection. I'll go grab my password for you. The goals application default.rb untitled. Where is the password? Yeah, forget after. Okay, I think I have my password. And the database name and username and password and everything is good. Huh? See, I must have forgotten. What is my password? See, if you don't do it in a sequence, you forget what password I chose. I've completely forgotten what I chose. But the point is, yes, it is working. And it took us 15 minutes practically. And we have it up and running, and you can now I can go back and in the digital ocean, I'll go destroy the droplet. Right? Because I don't want it. It is something that we are doing it as an experiment. So we are going to destroy this, build something today, and don't have to scrub data because there is no data, and just destroy and fine with it. So it destroys. So it's gone. So now your site will not open on that location. So let's see how you're doing. Okay, so it worked. So Apache got installed, and now did you try to kill it and heal it? Kill it and heal it? Okay. Kill and heal. Heal is the last step I wrote on the write-up, which is the right. Where did it go? Yeah, here. This is the last step is the heal step, and kill step is manually kill it, sudo kill.
Also, line 8 is still.
Yeah, line 8 is basically run chef solo again. Line 8 is run chef solo one more time, so it heals. And kill is you go create havoc by deliberately destroying stuff. If you want, you can, and still heal it.
Basically, just kill the process.
You could do whatever you want. Just throw the machine away and create a new one. Still works. It'll still work if you follow through the entire chain. It'll work. You throw the whole machine and create it again in the next 15 minutes. You have a new machine. If you automate the process end to end, you can actually do the whole thing in few minutes, literally. Or even go to the extent of beyond going that, is you have multiple machines ready. You can just switch over DNS. With a 1 minute time to live, and you just fail over, like from this location to that location, and things keep on running, and you just fail over.
What do you think is like first time installing Ruby, then Nine, and then Chef,
Yes.
then what do you
Then
do?
this I think you are at some. Which one did you run the last time?
I ran all of it.
I think you're.
I went into that script and checked.
So you added the whole thing. Did you modify the script? Okay. Then it'll run the whole thing step by step. Yeah. It'll run the whole thing one by one basically. That's okay.
Yeah, I just went into the script.
Makes sense. Makes sense. I modified the script. That makes sense.
So installing Ruby, installing Chef,
Yep.
installing Nine.
Yep. Exactly what it says. Exactly what it says.
And what does node.json do?
So let's read the node.json, right? And we'll understand what it does. So let's go and read it. So we did not even actually study it. We just said, we want to just do a quick run. We just want to do a quick run of what we do. So next time we meet Wednesday, we'll actually get to read what the code is inside. So right now we did not do anything. All we did is, just kick some tires. First day, chef, kick tires. And so we did. So now we'll go and examine what that thing is. Let's read that. And so I'll go back here and read that knife.json. There should be a file there here. Knife node.json. See what it says. It says use the temporary directory /tmp, and my run list should be my recipe called recipe main. That's the definition of what is my main recipe. What's my beginning point? I begin from my recipe called main. That's all it says here. And this file is the node.json file. Let's look at the other file, which is solo.rb. And here there are two lines in Ruby. The two lines are essentially saying that my cookbooks are stored in the folder called cookbooks, and my JSON attributes are stored in a file called node.json. That's what this thing says in Ruby language. My cookbooks are stored in the folder called cookbooks, and my JSON attributes are stored in a file called node.json. That's it. Now let us look at that main cookbook. The main cookbook is actually part of the cookbooks folder, and there it is. And if you go further inside, it says my main recipe is this. It says look at the package called Apache 2, and install it. And the next thing is start it and enable it. That's it. So this is outcomes I define. I need my machine to have Apache installed, started, and enabled. That's my outcome definition. Yes. It is my main recipe. And it ran. I defined my outcome. And it produced the outcome for me. I did not have to tell where to get Apache from, how to invoke it, how to start it, how to enable it, how to create configuration files, nothing. This is all I wrote essentially. Practically speaking, this is all the code I wrote. 3 files, node.json, that other file that we had, and this one recipe, which says, my outcome should be like this. And I'm done.
Git clone command, this thing in your image, clone image.
It, from that location, it copied the whole thing practically. It copied the whole thing into your EC2 machine. Copied from GitHub to EC2. So it gives you all these files ready to use. Yeah, all these files you probably got it from that git clone command. It copied the whole thing over. Right? Good. Oh, Apache is running now. Oh, so that's awesome. So yeah, we fixed the script on the fly without running it, and that's awesome. You see, Chef really works. Wow. Look at that.
So now can I do the same thing you launched on the server? Like
No, the thing
I am not.
the thing that I ran on WordPress and all that is a fairly involved project you will do, but not today. It was just a kick, just to show you what can we do. Like I started off an example of, let me show you what you can do. And so I took his domain name and I set up a site for him, and we have it running. It took me 15 minutes. but we'll build it together, right? We'll build it. I want you to understand step by step, build the components together so you actually do it, as opposed to me giving you a package. I can give you the whole repository right now, but that's not the point. I want you to build it yourself. Yeah, you build it and then you do whatever you want. It becomes yours. Make sense? Sweet. Aha. He's having a good time. Yeah, absolutely. Cloud.mycranville. He loaded up a empty page, HTML page with Chef Really Works page on his domain with a subdomain, CNAME alias, no, a record and pointed it and all that good stuff. DigitalOcean. Yeah. CNAME is named name. Yeah, it won't work. You need a name to number mapping. It's a record. The end-to-end solution, man, end-to-end. That is good. Can I stop recording for a minute? I think that'll help. Recording stopping now. Okay, there we go. Google Hangouts stop.